Tuturutututu, tuturutututu. हाँ, जल्दी जल्दी आज खत्म करना पड़ेगा हमें। दिक्कत हो जाएगा नहीं तो। ओह, नाइस। फालतू। बहुत इंक्लूसिव। लॉग इन में करना। ओहो, ओवा ओवा, पतवाला भाई। कोई को खुद से मिलाने चला है वो दीवाने। Pattern is changing. जस्ट ऐसे ही करके देख रहा हूँ। हम्म। निंद्रा में है हम।
7 का बाइनरी होता है हाय गाइस। तो इस सवाल में क्या करना है, आपको एक नंबर मिलेगा n, आपको n तक के सारे नेचुरल नंबर्स में जितनी भी बिट्स ऑन है उसका काउंट बताना है। तो एक तो क्या होता है कि एक नंबर को उसकी बिट्स काउंट करके हम देख सकते हैं, पर वो तरीका स्मार्ट नहीं है। ठीक है, देखते हैं कुछ और डेटा बन सकता है क्या। लेट्स से आपने मुझे नंबर दिया 11, 11 तक के सारे नंबर लिख देते हैं। 0 का बाइनरी होता है ये, 1 का बाइनरी होता है ये, मैंने 0 लिख लिया, हालांकि वो नेचुरल नंबर नहीं है, पर उसमें कोई बिट भी नहीं है तो कोई फर्क नहीं पड़ेगा। 2 का बाइनरी होता है ये, 3 का बाइनरी होता है ये, 4 का बाइनरी होता है ये है, 5 का बाइनरी होता है दिस, 6 का बाइनरी होता है दिस, 7 का बाइनरी होता है दिस, 8 का बाइनरी होता है 1000, 9 का बाइनरी होता है 1001 और 10 का बाइनरी होता है 1010 और 11 का बाइनरी होता है 1011। तो आपको 11 तक की सारी बिट्स काउंट करनी है। तो बहुत सिंपल क्या है, आप 11 से छोटी, 11 के बराबर 11 से छोटी 2 की सबसे बड़ी पावर ढूंढिए। द लार्जेस्ट पावर ऑफ 2 व्हिच इज लेस देन इक्वल टू 11। तो विच इन दिस केस इज 8, 2 रेज़ पावर 3 8 है, ठीक है। तो ये नंबर से आपको पता क्या मिलेगा, आप 8 से पहले वाले सारे नंबर्स में कितनी बिट्स ऑन है उसको झटके में निकाल देंगे। कैसे कैसे, ये देखिए इससे ना एक सेट पूरा हो जाता है। पहले वाली बिट को छोड़ दीजिए, उसमें सारे जीरो हैं, ये ट्रिपल जीरो स्टार्ट हुए थे, ट्रिपल वन तक पहुंच गए हम, ठीक है। तो बीच के सारे नंबर आ चुके हैं। तो अब देखिए क्या होगा इसके अंदर, पहली बिट को एनालाइज कीजिए, इतने नंबरों में एक ऑफ एक ऑन एक ऑफ एक ऑन एक ऑफ एक ऑन एक ऑफ एक ऑन, तो टोटल 8 थे जीरो के साथ, उनमें से आधों में ऑन आधों में ऑफ, तो 8 बाय 2 बिट्स आपको इस प्लेस पर मिलेगी। अगले में देखो 2 ऑफ 2 ऑन 2 ऑफ 2 ऑन, 8 बाय 2 और मिल गई। अगले में देखो 4 ऑफ 4 ऑन, 8 बाय 2 और मिल गई। तो देखो 8 तक आपको टोटल बिट्स कितनी मिल गई, 4 प्लस 4 प्लस 4 12 मिल गई, ठीक है। तो जो 2
हाँ
3 8 था वो ये इंडिकेट करता है 8 से पहले पहले आपको कितनी बिट्स मिल जाएंगी, 2 3 8 है ना, तो वो क्या इंडिकेट करता है, कितनी मिल जाएंगी 8/2, 8/2 एक प्लेस पे कितनी मिल रही है 8/2, और फिर कितने प्लेसेस मिल रही है 3 प्लेसेस मिल रही है, इस प्लेस पर भी इस प्लेस पर भी इस प्लेस पर भी, उससे आगे सब जीरो पड़ा है। 8/2 × 3, तो जो सबसे बड़ी पावर थी आपकी वो 2 3 8 था, तो आपको क्या मिला, मैं इसको 8 2 8 को लिख सकता हूँ 4 लिख सकता हूँ, तो बेसिकली मैं ऐसा लिख सकता हूँ, अगर 2 3 8 है तो आपको मिलेगा 2 3 -1 × 3। जो सबसे बड़ी पावर है लेट अस से वो है x, सबसे बड़ी पावर 11 के अंदर जो छुपी हुई है 2 की, वो है लेट अस से 2 x। तो आपको 2 x से पहले 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 मालूम कितनी बिट्स मिलने वाली है, आपको मिलने वाली है 2 x -1 × x, इतनी बिट्स तो आपको इससे पहले मिल जाएंगी। यहाँ पर जो x था वो 3 था, 2 3 8 होता है, तो आपको कितनी बिट्स मिल गई 2 3 -1 × 3, दैट इज 4 × 3 12, 12 बिट्स तो आपको यहाँ से मिल गई। अब इसे यहाँ देखते हैं, ठीक है। अब ये ना बिल्कुल पहले वाले जैसा है, लेकिन
ओ
हम लोग यार यहाँ सारे वन है शुरुआत में, मैं इन वन को सेटल कर लेते हैं। कैसे, इन सारे वंस को कैसे सेटल कर लें, 11 में 8 निकाल दो, कितने नंबर है 11 में 8 + 1, 11 में 8 + 1 लेफ्ट से राइट कितने बंदे हुए 4 बंदे हुए, तो इनके नाम का 4 सीधा सीधा ऐड कर दो। जैसे आपने पहले 2 रेज़ टू पावर x से नीचे वाले सबके लिए आपने क्या ऐड कर दिया था 2 x - 1 इनको ऐड कर दिया था। तो जो आपको सारे वंस दिख रहे हैं ना यहाँ पर मोस्ट सिग्निफिकेंट बिट में, तो इनके नाम का आप n - 2 रेज़ टू पावर x + 1 अलग से ऐड कर दो। 11 - 8 + 1, 11 - 8 + 3 3 + 1 4, तो इन 4 के नाम पे हमने 4 ऐड कर दिया। तो आपने हर का ये वाला बिट यूज कर लिया, तो साइन नंबर का इसमें यूज हो गया। इनका ये वाला बिट चला गया, तो ये नंबर यूज हो गया 000 में, ये नंबर यूज हो गया 001 में, ये नंबर यूज हो गया 010 में, ये नंबर यूज हो गया 011 में। इनका ये वाला तो आपने अकाउंट फॉर कर लिया। कैसे अकाउंट फॉर किया, n which was 11 - 8 + 1, n - 2 x + 1 आपने पहले इतने काउंट कर लिए, तो इन सबकी सबसे बड़ी वाली बिट उठा ली, तो ये वाली बिट उठा ली, तो ये नंबर इतने इतने रह गए। तो बेसिकली इफेक्टिव पता क्या हुआ इससे, हर एक में 8 का सबट्रैक्शन हो गया, 8 से वो बन गया 0, 9 से वो बन गया 1 का बाइनरी, 10 से वो बन गया 2 का बाइनरी, 11 से वो बन गया 3 का बाइनरी। ठीक है, हमने क्या किया, सबसे पहले 2 x से नीचे वाले सारे ले लिए, वो आपको मिल गए। फिर आपने 2 x से लेकर n तक के नंबर उनका ये सबसे बड़ा वाला बिट उठा लिया, वो ये मिल गया। ये वाला 2 x - 1 किसके लिए है, जो 2 x से छोटे नंबर उनके लिए, ये n - 2 x + 1 किसके लिए है, n - 2 x + 1 इनके लिए है, जो नंबर 2 x से लेकर n के बीच में थे उनकी सबसे बड़ी वाली बिट के लिए। कितने नंबर है 11 - 8 + 1 4 नंबर है, चारों का ये वाला बिट 1 है, उनके नंबर याद कर लिया। तो अब सिर्फ ये वाले अकाउंट फॉर करनी है, ये वाली अकाउंट करनी है, तो ये जो बचा ये नंबर 0 के बराबर है, 8 से वो 0 हो गया, 9 से वो 1 हो गया, 10 से वो 2 हो गया, 11 से वो 3 हो गया। तो बेसिकली आपको सेम प्रॉब्लम सॉल्व करनी है, लेकिन फॉर अ स्मॉलर नंबर, फॉर जस्ट 3। तो ले लेकर फॉर्मूला निकला ना, वो देखो क्या होना। अगर आप किसी ने बोला कि n के लिए सॉल्व करो, n के लिए बताओ कितनी बिट्स होंगी, तो हम n के अंदर सबसे बड़ी पावर 2 की ढूंढेंगे। तो मान लो x आई, तो फिर फॉर्मूला होगा 2 x - 1 × x, ये होगा सबसे बड़ी पावर जो x की वो 2 की छुपी हुई है उससे पहले वाले नंबर के लिए। फिर आएगा प्लस n - 2 x + 1, ये होगा 2 x से लेकर n तक जो नंबर्स हैं उनकी सबसे बड़ी वाली बिट के लिए। और फिर आपके पास क्या बच जाएगा, सॉल्व n - 2 x, सिर्फ
सही है।
इन नंबर्स के लिए। आपके कितने रह गए नंबर, आपका जो नया नेचुरल नंबर होगा वो 3 तक आपको ढूंढना है। क्यों, क्योंकि आपके नंबर ये बचे। इफेक्टिव आपने काउंट कर लिया, तो आपके नंबर ये बच गए। अब सबसे छोटा नंबर कौन है 0, जो 8 था वो 0 बन गया, और जो 11 था वो क्या बन गया 3, मतलब जो 2 की सबसे बड़ी पावर जो 2 की पावर x था वो 0 बन गया है, और जो n था वो बन गया n - 2 x। तो मैंने बोला जो सॉल्व फॉर n - 2 x, तो बेसिकली कह रहा हूं 3 तक के नेचुरल नंबर्स में सबकी बिट काउंट कर दो। अगर ये सॉल्व हो जाएगा फिर पूरा सॉल्व हो जाएगा। तो लेकर ये फॉर्मूला बना, ठीक है। तो आइए सॉल्व करने की कोशिश करते हैं, शुड नॉट बी टू हार्ड। फिर निकालने नंबर की और ट्राई करेंगे, देखिए हमारा स्ट्रैटेजी सही है कि नहीं। तो मुझे सबसे पहले चाहिए वो फंक्शन जो मुझे 2 की पावर बताएगा, 2 की सबसे बड़ी पावर, लार्जेस्ट पावर ऑफ 2 इन रेंज, ठीक है। तो आपने मुझे इंट n
मतलब लॉगरिथमिक लगा देंगे।
पास किया है, तो x मैंने 0 रखा, 2 की पावर बनाने का तरीका मैं आपको बताता हूं, 1 goes to x से 2 की पावर बन जाती है, 1 goes to x। अगर ये नंबर लेस देन इक्वल टू n है तो आप x को बढ़ाते हैं, ठीक है। तो देखो हमने क्या किया, जैसे अगर ये वाला लूप जो मैंने लगाया हुआ लिखा हुआ आपके सामने, इसको सोचिए। देखिए अगर मैं आपको देता नंबर 10 10 के लिए सोचिए, x 0 है, तो 2 0 जी, देखिए कैसे चलेगा, x को मैं 0 लेके चला हूं, और 10 के लिए सोचें 2 0 होता है 1, जो लेस देन इक्वल टू 10 है, तो 0 को बढ़ा के 1 कर दीजिए, 1 हो गया, ठीक है। 0 को बढ़ा के 1 कर दिया, तो अब अगली बार आपका x आपका बढ़ गया। अब आप टेस्ट करो, 2 होता है 2, वो लेस देन इक्वल टू 10 है, फिर बढ़ा दीजिए, 2 2 4 लेस देन इक्वल टू 10 है, फिर बढ़ा दीजिए, 2 3 8 लेस देन इक्वल टू 10 है, फिर बढ़ा दीजिए, 2 4 16 अब लेस देन इक्वल टू 10 ये रूप से बाहर आ गए। पर आपके पास आ गया 2 4 16, आपको ये नहीं चाहिए, आपको 2 3 8 तक ही चाहिए, 10 से छोटे या उसके बराबर जो 2 की सबसे बड़ी पावर है, आपको उसमें इंटरेस्ट है, ठीक है। तो आप यहाँ से रिटर्न करेंगे x प्लस ये x रिटर्न करेंगे, x माइनस 1 रिटर्न करेंगे, ठीक है। तो आपको सबसे बड़ी 2 की पावर मिल गई, तो मैं बोलूंगा x बुला देते हैं, जैसे x बुलाएंगे तो ऑप्शन मिलेंगे लार्जेस्ट पावर ऑफ 2 इन रेंज, ठीक है। अब हमें ये x मिल गया जो 2 की सबसे बड़ी पावर है, बेसिकली 3 मिल गया। जैसे आपको 11 के लिए 3 मिल गया, 3 क्या है 11 के लिए 3 है 2 3 वाला 8, जो 8 के कॉर्रेस्पॉन्डिंग 2 3 होता है, वो 3 मिल गया, x मिल गया। तो अब आपको 0 से 7 2 x से छोटे-छोटे सारे नंबरों को कंसीडर करना है, वो कैसे कंसीडर हो जाएंगे, 2 x - 1 × x। आपने देखा पहले बेस पर भी 4, दूसरे बेस पर भी 4, तीसरे बेस पर भी 4, 2 3 8 था, पहले पर भी 4, तो मतलब पहले पर भी 8/2, दूसरे पर भी 8/2, तीसरे पर भी 8/2, तो 8/2 × 3, 8/2 कितना हुआ, 8/2 हुआ 4, 4 × 3, और 4 कितना हुआ, ये 2 3 8 है, तो ये 2 2 × 3 हो गया ना, तो इसलिए 2 x - 1 × x। तो बिट्स अप टू 2 रेज़ टू पावर x, 2 रेज़ x, कितनी हो गई बिट्स, 2 x - 1 × x, x into 1 goes to 2 raised by x - 1 करना था, तो ये हो गया 1 goes to ये जो चीज मैंने आपने की, ये 2 raised by x - 1 लिखा है, ये 2 raised by x - 1 होता है, ठीक है। और उसको मल्टीप्लाई करके तो आपको मिलेगा x into 2 raised by x - 1, तो आपको बिट्स अप टू 2 raised by x मिल गई, ठीक है। अब आपको क्या चाहिए, अब आपको चाहिए 2 raised by x से लेकर n तक जो सबसे बड़ी बिट है, तो कितने नंबर हैं 2 raised by x से लेकर n तक, कितने नंबर होते हैं, तो n - 2 msb फ्रॉम 2 raised by x to n, बिट डाली तो अब 0 बन गया, 9 more bits 2x, bits of 2x, significant bits from 2 raised by x to n, प्लस अब जो रेस्ट बच गया रिमेनिंग, रेस्ट है n minus 2 raised by x. 1 goes to x. ठीक है, क्यों? अब आपके पास बच गया ये, आपको मिला था 0 से 11 और अब आपके पास बच गया 0 से 3. 0 से 3 मतलब n minus 2 पर x चला गया. ठीक है, तो रेस्ट है आपका n minus 2 पर x. तो सॉल्व सॉल्यूशन ऑफ रेस्ट. ये हमारा आंसर होगा. तो हमारा काम कब रुकेगा ये जाकर? जब ये काम तब रुकेगा जब n 0 हो जाएगा. n अगर 0 होगा तो 0 नहीं होती एक भी बिट. तो हम रिटर्न क्या करेंगे? 0.
Whoa, yeah man, whoa. बेबी भी ट्राई करें, ट्राई किया जाए. चैट वैट में कुछ है क्या? आओ दोबारा मिल गए कहीं तो दोनों मिल जाए दोबारा. अनहद आए जब यादों से फिर तुम लौट आना दोबारा. ऐसी रातें ऐसे हम log to happiness. Highest, highest power of three. ऐसी रातें. अब क्या करेंगे? कतरा कतरा इश्क गुलाबी बादलों का चेहरा है कर गए हैं जितने आशिक मेरी चाहतों चले नाम तेरा होठ लगाए इश्क है कि पूरा है. int till highest power कितना होगा? न्यू 2 की पावर माइनस इंटू हाईएस्ट पावर। ओके, हाईएस्ट पावर हो गया। अब क्या है? हाईएस्ट पावर से एंड क्या हो गया हमारा? 2 की पावर 2 की पावर ऑफ 2 एंड माइनस। ठीक है, अभी क्या? कटिंग माइनस 8 एंड आएगा क्या रे? 13 minus 8 gives us 5 and remaining count set bits. पूरा है। ऐसे रात में। अगर एन वन आया तो ये मेरा जीरो होगा। ठीक है, एन वन आया तो भी जीरो। एन वन आया तो हाईएस्ट पावर फिर मेरा जीरो। फिर टिल हाईएस्ट पावर में करने जाता हूँ तो वन की पावर माइनस की पावर माइनस फिर टू आया तो वन जीरो प्लस जीरो इज वन। टू की पावर जीरो इज वन इंटू क्या होगा। है तो हाईएस्ट होगा टू माइनस हाईएस्ट पावर से। तो टू माइनस वन की पावर वन। टू की पावर वन सॉरी प्लस वन। हाँ, ऐसा होगा ना। वन जीरो। ठीक है, टिल हाईएस्ट पावर तो कितना होगा, ये वन होगा। हाईएस्ट पावर मेरा वैल्यू वन है तो इसलिए हम माइनस वन एट एट इंटू हाईएस्ट पावर टू वन तो ये वन आ गया। तो इसके बाद क्या है एन माइनस टू माइनस टू की पावर भी प्लस वन। तो ये हमने कैलकुलेट कर लिया। अपने रिमेनिंग क्या किया, एन में से माइनस कर दिया, मतलब टू में से माइनस कर दिया। ठीक है, वो डी डी ले आई तेरी याद तेरी सादगी हमें आपके इश्क नाम में ढल गए। ना 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 लाए हो तेरे तुझे हो लाए हो ऐसी रात उदासी हमने
ठीक है, तो ये आपका फॉर्मूला बनता है।
XM2 कतरा कतरा इश्क दीवाने बात वो कतरा है करोगे है कितना आपको मेरी चाह पर कनाए नाम तेरा होता है तेरा है got it ओके हो गया हमारा फटाफट प्रोग्रेस अपडेट किया गया 141 बोलते find whether the number is a power of 2 or not really मेरी चाहत पर तले नाम तेरा होता है इश्क है तेरा है na 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 होता है तेरा तेरा है तेरा इश्क है पागल तेरा है इजी जीरो में क्या था पैरों में ऑर्डर मेरी टांगे होगी भारी पीके निकली बटन मेरी जांगे होगी भारी तेरे गए चाहे तो चले now what 142 डन आज थोड़ा जल्दी जाना पड़ेगा पता है मतलब खत्म करना पड़ेगा जल्दी क्योंकि हमें जाना है given a number and only have one and all zeros 11 find the position of the only set bit if there are zeros or more than one set bit in a should be minus one position of the set bit कतरा कतरा इश्क बुला दे कोई ख्याल तो चले नाम तेरा हो लगाओ इश्क है तो ये वाला प्रॉब्लम हमें कह रहा है कि हमें ढूंढना है सेट बिट का पोजीशन। ठीक है, सेट बिट का पोजीशन हम कैसे ढूंढेंगे बताओ। और अगर एक से ज्यादा सेट बिट आ जाए तो फिर ये कर, तो हम क्या करेंगे, एक इंट एक्स लेंगे। ठीक है, इंट हमने एक्स लिया, तो तेरी चाहतों में कतरा कतरा, या फिर इंट एन ले लो, इंट एन भी नहीं लेते हो। ठीक है, वाइल एन, हमें क्या करना है, कुछ नहीं करना। फिफ्टीन पर उंगली और उंगली और शब्दों से, ये अपना आंसर है। हमारी जुआरी तो आ रही सास। अपने को तो एडवाइस पोजीशन देना है। तो इसको -1 कर दो तो हाँ, मतलब आंसर को सही है। हाँ, पॉज। Yeah. If n underscore one, तो हमें if answer equal to minus और आंसर इक्वल टू माइनस वन और फिर हमें क्या करना है आंसर इक्वल टू कॉस प्लस वन अगर आंसर इक्वल टू माइनस वन एल्स क्योंकि अगर दो सेट बिट हो तो खत्म है ना नाम तेरा हाय ब्रो हेलो विजय कुमार हरीश बंडला बांडला हेलो एक ही सेट बिट है इसमें given a number n having only one one and all other zero find the position of the only set bit if there are zero or more than one set bit answer should be minus one. Bro, explain the code in Java, bro. I can explain the pseudocode, but like I am not comfortable in Java. But I can explain the pseudocode and which language should you use. I am using CPP, and what should you use depends on you. Whatever you like, you can use. Don't use HTML. Okay. Okay. So let's start. But first, let me see why there is why my answer is answer. Okay. You see, this is why. If we are increasing it, then there is no need to update the end. No, just write like this. This is much better. Or you can just shift right like this and equal to n one better. Now it will work. I'll tell you. Just do it. Explain the pseudocode. Yes. Okay. Let's start. First, let me check the test case where it was failing. Is it working now? Yes. Okay. So let's start with the test case. Let's say uh, one, or you can say 0 0 1 0. Let's say we will take 0 1 0. Okay. Bro, I am learning Python language and then I start DSA. Is it okay, or should I start DSA and learn both sides? No, no, no. You first of all get comfortable in any one of the languages. Then you can start learning DSA. Okay, let's start with the pseudocode. So let's say our test case is 0 1 0. Okay, we will learn through the test cases. Okay, that is n is equal to 2. N is equal to 2 means 0, 1, 0. Okay, or 1, 0, whatever you want to say it. Okay, 1, 0. Now, my answer is minus 1. The question is saying is that the given number n has 1, 1, 1, that is the occurrence of 1 is 1 and rest are zeros. Okay, so you have to return the position of the 1. Okay, and if there are more than the occurrence of 1 is more than 1, then you have to return minus 1. Okay, so now let's start. So the position of 1 here is 1, sorry, the position of, and also you can see here that the position of the set bit 1 should be starting with the with 1 from the LSB. Okay, so now hear me out. There, as you see, there is only one set bit and its position is 2. Okay, so here you can see how its position is 2. Okay, so here it's 1. My bad. I'm not able to write. Okay, you will just give a space in between. Okay, now you can see the position of 0 is 1, the position of 1 is 2. Okay, bro, where you learn DSA from, any playlist or YouTube channel suggestion? I'll tell you after explaining the pseudocode. Okay, then let's say what we will do. We have initialized an answer variable to minus 1. Why we have done that? I'll tell you. Okay, now there is position 0. Okay, now what are we doing? We are we wrote a while loop inside it. What we are doing? We are doing AND with 1. That means if we found a set bit on that position, okay, let's see. 1 0 AND करेंगे हम किससे? We are doing AND with, we write AND here, with 1. What will be the output? What will be the output? It will be 0, obviously, right? So it will give us 0. Okay, but if it is giving us 0, then what we will do? We will increase the position to how much? 1. Okay, now position has become 1. Okay, and we are right shifting n. We are right shifting n means this is our n 1 0. We are shifting it by 1. That means this 0 will not be there anymore. So it will become just 1. So we have done it. So we have reduced the n from 2 to 1. Okay. Now we will do the same. Now, now the test case becomes n is equal to 1. Okay. Our position is 1. Okay. Now we will see if n, that is n is 1, we will do end with 1. If this becomes 1, obviously it will become 1. Then what we will do? We will check if this is already, our answer is already set or not. Okay, so let's say there are more than one set bit, then this answer wouldn't be minus 1, right? So if it is not minus 1, we will straight up return minus 1. And if it is not, like if it is minus 1, then what we will do? We will just update our answer to position plus 1. That's it. What is the value of position? It was 1. So as we have been told that we have to start from 1, the index counting should be starting from 1. So we will do position plus 1. Okay. Now let's check for the test case where it will return minus 1. Okay. Let's do for 3. Okay. Let's end it. I mean, we'll do end operation with 1. What it will give us? It will give us 1, right? So it will give us 1. Now, our answer is minus 1. We will get in this case, our answer is minus 1. So we'll update it to Position plus 1. What is the value of our position? 0 initially. So our answer is, now our answer is 1. Okay. Now we are left shifting 3 by one place, so it will become 1. If you do AND again with 1, you will get 1. You will get inside this case. Then you will check here. Your answer is minus 1. No, your answer is not minus 1. Then you will return minus 1. Okay. So yeah, that's it. Now let's see. Bro, I'm learning where you learn DSA from, any playlist or any YouTube channel? Okay. I started with a GFG course. Then in that I didn't understand some of the topics. So then I switched to YouTube. So if you like, do you want me to suggest some good playlist or anything like that? Tell me. I'll suggest. I will suggest you. No worries. I can suggest you. Yes, okay. So Ritesh is using Python as his language, right? So if you are using Python, no. I think neat code, you've heard of neat code. Not lead code, L for lead code, not L, it's N. Neat code. Neat code, DSA, Python. I think he
So you want to be a
explains
software engineer?
everything in
Hey everyone, welcome back.
Python only.
Pointer on day 1, and so this is
Yeah.
just the
See, so if you are using Python, you can go with code, and like I think he has solved almost every problem of lead code in his channel. Not every, like most of the important problem he has solved. So you can go for it. And let's say another resource, you can go Striver DSA, then click on the first link. Then you will be seeing here all the like this is the playlist for DSA, whole DSA. Oh, okay. See, now you can go in one of this. You will find it. The Python code is here or not? Okay, this is SC++ basics. Okay. Let me check other, like let's check a question. Solve on array. Okay, for Pascal triangle. Code. Yes, it is given in Python also for every question. You can see, okay? So you can go and check out here too if you don't get any answers or you are confused with the solution or you are not able to build up the logic, you can come here and check the solution also. Or you can just start uh, solving this playlist. It has around 4 to 450 questions. Now, cello, sulululu. Copy set bit in a range. What is it? L is equal to 2, R is equal to 3. 23. What is this? 23. The bit in the range 2 to 3 in the binary representation of 17 are set. What? Hmm. हाँ क्या so just set all the bits in the range. Oh, I need to add in the binary representation. दासे हमने no 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 कतरा कतरा इश्क गुलाबी का छोड़ा है नाम तेरा होठ लगाए इश्क वही पूरा है कर गए हैं कितने आशिक ये तो इजी है दिस इज इजी वी विल जस्ट run a for loop from L to R. We will do left shift of I, not I, yes. We will do left shift of one with the with I. Yeah. Return and oh, okay. I minus one, I think I should be doing. No. Hmm. Oh yeah, I minus one. Let's check now. What I did. Nothing. Nothing. He told me to sort. He told me to set all the bits in the range of 2 to 3 in the n given. So what is n? Let's check for test case. Okay. Our n is 10001. Okay. Now, what is our L? L is 2. We have ran a for loop from L to R. What is the value of I for the first iteration? It will be 2. So we are left shifting what? 1. So if I want to, this is the position second. This is the second position. Now, this is the second position. This one, the highlighted one, is the second position. If I want to set bit here, set a bit here, what I can do? What I will do? I will just 2 and 3 and 3. Okay. Uh, if I'm left shifting 1, 0. Okay. So I will be left shifting 1 with I minus 1 positions. Okay. So for first iteration, what is L? What is I? I is 2. So I will left shift 1 by 1. With this, that is I minus 1. So 2 minus 1. That is 1. So we will left shift. Oopsie. Left shift. Now we are doing OR operation for it. Right. If we are doing OR operation on it, then what will be the answer? 1, 0, 0, 1, 1. So we are updating n as it is. as we are going in the for loop. Then again, the I updates. What will be the value of I? Now it will become 3. So what can I do? I will just left shift my 1, okay, to here. Now I'll do OR. What will be my value? 0. Oops, 0. 1, 1, 1. And our for loop ends and we will return the end. Okay, got it. You got it. Let's try to submit it. Okay, 144 questions finished. Hmm. Given two integers, dividend divisor. Find the quotient. Okay. Huh. Oh, 309 subscribers. Crazy. Can we reach 310 subscribers, guys? Can we reach? Can we reach? Guys, come on. इतना तो हो ही सकता है यार. अगर हम 310 पहुंच गए तो मैं एक बढ़िया सा गाना सुन. नहीं, 312. 312. मैं 312 पहुंच गए तो मैं अच्छा सा गाना सुनाऊंगा. ओके. ओके. डने डने डने. बताओ. Without doing multiplication, division, or mod operator. If the quotient is strictly greater than to give out 31 minus 1, return the quotient is strictly less than. Legend is here. 21 coders. Hello, bhai. Hello. क्या चल रहा है? Legend is here. क्या हाल है भाई? और बता. बस बढ़िया भाई. तू बता. डिविडेंड एंड डिवाइजर. फाइंड द क्वोशंट आफ्टर डिविडेंड. ठीक है. कुछ तो कर ही सकते होंगे हम. बिट मैनिपुलेशन में हमें डिविजन डिविडेंड कैसे निकालना है? बिट मैनिपुलेशन में देखना पड़ेगा. हम्म. सीने पे जो रख दो तो हाथ मेरे चल जाए. चाहे मेरी जान जाए. Hi, bro. Hello. Akhilesh Vinny. Akhilash Vinny. Akhilesh. I didn't understand this problem. Which problem? Are you talking about division? Akhila. Sorry. Akhila. Akhila. Yes. Sorry. What? This one? Okay. This problem also I am not able to understand. I'm trying to solve it right now. If I get the logic, then I'll explain it to you. And if we didn't got the logic, we'll see what we can do. We'll check hints. Or we'll check if it is previously submitted by me. You can check my previous submission also. Or we can check comments, we can check YouTube solutions. Hmm. Akila, what can we do here, Akila? You have any suggestions? सीने पे जो रख दूँ तो फिर मिल जाए चाहे मेरी जान जाए चाहे मेरा दिल जाए अन्ना की तमन्ना है कि हीरा मुझे मिल जाए चाहे मेरी जान जाए uh, we can check the hint as every number can be represented by in base 2. Okay, represent the quotient in binary. What? Represent the quotient by using shift operator. What are you trying to do here? Represent the quotient in binary form by shift. Oh. Newton ने समझा. What can you do? अरे 309 द सब्सक्राइबर अभी भी 309 ही है करा दो यार करा दो सब्सक्राइबर बढ़वा दो हम्म, वन एच पी अल्फा पी कौन सी ईयर में है भाई ग्रेजुएटेड रीसेंट ग्रेजुएट मजा आया कि नहीं सुन के आओ देखते हैं यार क्वेश्चन मैंने प्रीवियसली सबमिशन कुछ किया है नहीं किया है कमेंट में से देख ले या यूट्यूब पे से देख ले इजीएस्ट वे अबे ये तो नहीं करना है ये तो करना है ये तो मैं ऐसे करूंगा तो सबमिट हो जाएगा उसमें क्या है ये भाई कुछ लोग है ना भाई ऐसे कर रहे हैं सीधा सीधा इनको यही नहीं है भाई ऐसे तो होना ही है सबमिट, देखो पर स्ट्रिक्टली लिखा है। देखो कोई भी सवाल दिया जाता है वो सॉल्व करने के लिए नहीं दिया जाता। ओ ओके ओके 2025 है, यस यस यस, सॉल्व करने के लिए नहीं दिया जाता, तुम्हारा लॉजिक बिल्डिंग स्ट्रांग हो इसलिए दिया जाता है। कोई, ये तो इजीली होना ही है अपने से, है ना, सीधी बात है। ये देखो होना ही है, कुछ लोग समझते ही नहीं। बाइनरी सर्च, हम्म, बाइनरी सर्च का रेंज कैसे ढूंढूं मैं? थ्री, आई थिंक ये 3 से 10 के बीच में होगा बराबर। पर उसमें भी अगर मेरा डिवाइस है, पर ये बाइनरी मैनिपुलेशन के अंदर है ना, इसलिए मुझे समझ नहीं आ रहा है कि मैं 3 से 10 मेरा ले भी लूं, चलो, पर कहीं ना कहीं तो मुझे 3 को मल्टीप्लाई करना पड़ेगा ना। हाँ ना, इसमें मल्टीप्लिकेशन भी मना किया है। वो तो मैंने सोचा था, समझ रहे हो, समझ रहा हूँ तुम लोग की बात। मिड इनटू डिवाइजर लेस देन इक्वल, मल्टीप्लिकेशन डिवीजन मॉड ऑपरेटर यूज ही नहीं करना है, ऐसा है, समझ रहे हो। नहीं तो अपन कर लेते ना पहले ही, समझ रहे हो, गॉट इट। अल्फा भाई कोई और रास्ता सोचो, जल्दी सोचो। अल्फा भाई, अल्फा, दूसरा रास्ता अपनाना पड़ेगा हमें। जल्दी बताओ, क्या तुम्हारे पास कोई रास्ता है? तेरे पास कोई और प्लान है? ऑपरेटर नहीं यूज होगा, मल्टीप्लिकेशन यूज होगा, पर ये जो आपने ऑपरेटर लगाया ना, ये वाले स्टार स्लैश और परसेंटेज, वो यूज नहीं करने कहीं पे भी। ऑब्वियसली मल्टीप्लिकेशन होगा पर बिना ऑपरेटर के कुछ करना है, ऐसा बोल रहे हैं ये लोग। बिटवाइज, मतलब इन्होंने यही किया है, बोल तो वही रहा है शिफ्ट ऑपरेटर यूज कर रहा है, पर मैं इसमें दिमाग चला नहीं पा रहा हूँ कि शिफ्ट ऑपरेटर कैसे, कहाँ, क्यों, कब। गॉड बिग ऑफ वन, बिग ऑफ वन। चलो कोई बात नहीं, लेक्चर देख लेते हैं फटाफट। धूमता ना 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 ना, धूमता ना 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 ना, धूमता ना धूमता ना धूमता ना धूमता ना, ड्राइवर भाई।
So let's continue with the bit manipulation playlist and Strivers A to Z DSA course. But before that, hey, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we will be solving today is divide two integers. The catch over here is you cannot use the division operator. So you cannot use it. So you'll be given a dividend, you'll be given a divisor, and they will be in the range of integer, which is basically minus 2 to the power 31 to 2 to the power 31 minus 1. That's the range. And the divisor will never be 0. So you'll be given a dividend, you'll be given a divisor. Now your task is to divide them. So if you divide them, you'll get 7 point something. You'll have to return down the integer value, not the decimal. You can truncate everything after the decimal point, and you'll have to return me the integer value. Now, in case, let's assume you're given a dividend which is something like minus 2 to the power 31, and you're given a divisor which is something like minus 1. Now, if you go ahead and divide it, what will happen is the value that you'll get is 2 to the power 31, and this one cannot be stored
in an integer range, because the integer range will only store from minus 2 to the power 31 till 2 to the power 31 minus 1. I've already explained why does it happen in my first lecture. Go back and watch it. So if something like this happens, what you'll be returning is the maximum value, which is basically this one, integer max. Integer max is 2 to the power 31 minus 1. That's what you'll be returning. And similarly for the negative as well, if the negative overflows, you will be returning integer minimum. Got it? So what will be the first solution that comes to your mind? The extreme range solution that I can think of is, okay, I'm going to start with 3. I'm going to add another 3, that's 6. I'm going to add another 3, that's 9. Another 3, that's 12. Another 3, that's 15. Another 3, that's 18. Another 3, that's 21. Beyond this, I cannot add. So I'll keep on adding divisors till I can. So the number of divisors that I could add was 7, and that's going to be my answer. Now this will work. If I have to write down the code, it's going to be, okay, initially we can start with 0 and a counter 0, where I can say value instead of value, I can say sum. That's a better one here. Sum is 0 and counter is 0. Okay, cool. I'll add the divisor once to the sum, and I'll check if that's not exceeding the dividend. And that's okay. I can do a counter equal to counter plus 1. That means I'll add it once. As a sum plus equal to the divisor. I'll keep on doing till I can. And at the end of the day, I can print down the count, and that will be it. But what will be the time complexity of this one? Will this work? Now imagine you're given a divisor as 1. Just imagine you're given a divisor as 1. In that scenario, the time complexity will be big O of dividend, right? Because if you're given a huge number like 2 to the power 31 minus 1, and you're given the divisor as 1, gonna add it on till 2 to the power 31 minus 1 times. That's a lot of thing, and it will be giving you a time limit exceeded. But this is where this solution doesn't work, and the interviewer will ask you to optimize this. So I know one thing: I need 3 into 7, right? Like I have to multiply the divisor by 7 times. Can I derive something out of it so that I can do it in a faster way? Maybe yes. Let's see how. Can I write 7 as powers of 2, like the 7 as powers of 2? Maybe yes. I can write it as 2 to the power 2, which is 4, 2 to the power 1, which is 2, plus 2 to the power 0. Makes sense, because this is 4, this is 2, and this is 1, and if you add them up, you'll get 7. Okay, so that technically means if I just open up the brackets, that's 3 into 2 to the power 2 plus 3 into 2 to the power 1 plus 3 into 2 to the power 0. Now I know one thing: every number can be written down in powers of 2, like summation of powers of 2. We know that for sure from bit manipulation. Okay, so can I say the first thing that I'll remove from 22 will be not 3, rather 12. 3 into 2 square, that's 12. That is the first thing I'll remove. And then I'll remove 3 into 2, which is 6, and then I'll remove 3 into 1, which is 3. So instead of adding on 1, 1, 1, I'll do the other way. I'll try to remove the bigger number. That's this one. How do I figure this out? It's very simple. What I do is I use 7 over here. So I did a bit of reverse engineering, and I did figure this out that we'll have to play in terms of powers of 2, right? I did a bit of reverse engineering. Now I'll try to do it in the forward engineering. How can I do that? It's going to be very simple. I know one thing: from 22, I have to remove 3, but in powers of 2. First power of 2 that I can remove is 3 into 2 to the power 0, which is 3. I can remove it. Maybe I'll try to look to remove a bigger number. That's 3 into 2 to the power 1. That's 6. I can remove 6. 3 into 2 to the power 2, which is 12. I can remove 12 as well. 3 into 2 to the power 3, which is 8 into 3, 24. I cannot remove 24. So the biggest number that I can remove will be this one.
Okay.
So try to remove 12. So I remove 12. The number that I left out, the number that will be left out will be 10. Correct? So I removed 12, and that was 2 to the power 2. 3 into 2 to the power 2. So just store it somewhere, which is typically 4. Store it somewhere. Okay. I'm left out with 10. Can I remove 3 into 2 to the power 0? That's 3 from 10. I can. Can I remove 3 into 2 to the power 1? That's 6. I can. Can I remove 3 into 2 to the power 2? That's 12. I cannot. So typically, I can remove 6. So I'll be removing 6, and I'll be left out with 4. How much did I remove? 2 to the power 1. That's typically 2. Perfect. How much am I left out with? 4. Let's try. 3 into the smallest. 2 to the power 0, that's 3. Can I remove 3? I can. 3 into 2 to the power 1, that's 6. Can I remove 6? I cannot. So typically, I can remove 3 from it, and I'll be left out with 1. So I've removed 2 to the power 0. That's basically 1. Done.
Okay.
I'm left out with 1, which is lesser than the divisor, So I stop. I put a stop because I cannot remove any further. How many did I remove? How many 3s did I remove? In total, 7. So that's your answer. I did a bit of reverse engineering, nothing special. So before I move on to the code, there's one more thing that we need to discuss. What if the numbers are negative? Now we are looking for the answer, correct? The answer will only be negative if the numerator is positive and the denominator is negative, or the numerator is negative and the denominator is positive. Only in these two possible scenarios, the answer, when you divide, the answer will come out to be negative. In every other scenario, the answer will be positive. So this is how we can easily address the positive and negative scenario. What we will be doing is, we're taking a positive numerator, a positive denominator, and we will divide it. Once we're done with it, we will add a sign to it. Initially, we will not be working with the sign. We will divide it, thinking that both of them are positive, and then we will add the sign depending on these two conditions. That's how I will be approaching this one. So we'll be trying to write down the solution, and then we'll be talking about overflows and everything else. But first, let's try to write down the pseudocode. So function, you'll be given a dividend, and you'll be given a divisor. Let's get rid of the initial edge case, which is, hey, what if the dividend is equal to the divisor? So in that scenario, please go ahead and return 1. That is the basic scenario. Now, if I ask you, hey, what about the sign? Let's assume initially the sign is true. True over here means it's a positive. I know one thing, it will only be negative if the dividend is greater than 0, which is a positive number, and the divisor is lesser than 0. In this scenario, the sign will be false. And the other scenario can be if the dividend is lesser than 0 and the divisor is greater than 0. In that scenario, the sign will be false. False over here means a negative. Okay. So I've dealt with the sign thing, right? Now what is the next thing? I need to make sure that both of these numbers are positive. So we're done with the sign thing. Now what is the next thing? We will be operating with positive numbers. So let's take the absolute of dividend and store it in a variable known as n. And let's take the absolute of divisor and store it in a variable d. Let's assume the initial is 22 and is 3. What were we doing? We were checking 3 into 2 to the power 0, which is 3. I'm very sure this is possible, right? This is possible. And then this one. I'm very sure this is also possible. I'll keep on doing it. And we figured out that 12 was the first number, was the last number till which it was possible. Then we removed 12 and we were left out with 10. And then again we started for checking for which 3 was it possible. So first we do with 22, then with 10. So we were doing multiple iterations. Thereby I can say, okay, I will be doing the iteration till I know the denominator is lesser than equal to numerator. That means I can still remove. Perfect. I'm very sure that counter 0. Now what do I mean by counter 0? 3 into 2 to the power 0, this 0. I can remove this one. I'm very sure. I need to check, can I remove the next one? Why am I sure? Because if I'm checking for this one, that automatically proves it. Okay, let's check for the next one. Till how much can I remove? I'm like, okay, numerator greater than equal to, I know the denominator is 3 into 2 to the power counter plus 1. Let's check for the next one. That's what I'll write. That's what I'll write, isn't it? Because the counter is 0. I'll check for the next one. Can it remove? And if it can, maybe I'll do a counter plus. Maybe I'll do a counter plus plus. Makes sense, right?
Hmm.
Let's check for the next one. Till how much can I remove? I'm like, okay, numerator greater than equal to, I know the denominator is 3 into 2 to the power counter plus 1. Let's check for the next one. That's what I'll write. That's what I'll write, isn't it? Because the counter is 0. I'll check for the next one. Can it remove? And if it can, maybe I'll do a counter plus plus. Maybe I'll do a counter plus plus. Makes sense, right? So
See,
we're checking for 3 into 2 to the power 1, then 3 into 2 to the power 2. And that's the max it can do, because when counter reaches 2 and it checks for 2 to the power 3, it cannot, because this will be 24 and hence this condition will be false. Okay, done. Can I just rewrite this as d left shift of counter plus 1? I can, because this is equivalent to writing d into 2 to the power counter plus 1. Simple bit manipulation. Simple bit manipulation. When you do a left shift operator with some value, it goes to the power of 2. Perfect. So I know this much can be removed. So thereby, can I say my answer? Maybe you can take an answer as 0, and you can say, okay, answer plus equal to 2 to the power count, because that many 3's can be removed. If you remember, initially we could remove 3 into 2 to the power 2, which was 12. So you added 4 to your answer. So I've added 4 to my answer. Again, 2 to the power count can be written as 1 left shift of count, because this is nothing but 2 to the power count in bit. Okay, done. Now what is the next thing? I need to take it out of the number as well. Numerator minus, how much will I take? 3 into, so that's divisor, into 1 left shift of count, because that is the number that I'll be taking out. That's number d into 2 to the power 2. Initially 3 into 2 to the power 2 is what I'll be taking up. And again, after this iteration, I'll again come over here, where n will be 10 and d will still be 3. And I'll again find out what's the minimal power 2 that I can do. It'll keep going. So once the division is completed, this answer will be storing your answer. And if you remember, there were some conditions. So you can just keep a check, because we know the answer will always be positive. If the answer goes beyond 2 to the
पर
power 31, because this cannot be stored. The
इन लोग
maximum
ने
integer
बिग
can
ऑफ
store is
1 में
this one.
किया है.
Thereby, if it goes beyond this, and the sign is positive, which is true, you will be returning an integer max. That's what you will be returning. And you can have one more condition where the sign is negative and the answer is exceeding 2 to the power 31. In this scenario, you will be returning integer min. Done. And if both of the scenarios do not match, you have a valid answer. If you have a valid answer, please return according to the sign. If the sign is positive, you return the answer, or else you can return -1 into the answer, because it will be adding the minus sign and the function. So this is how you can easily do it. So it's time to discuss the time complexity of the section of the code that we have written. We have an outer while loop, we have an inner while loop. So we know something into something will be the time complexity. First of all, this is getting reduced like 22, 10, and then so on. And what are we reducing? 22, we wrote it as 3 into 7, and the 7 was 4 plus 2 plus 1. That's a logarithmic representation of 7, like in powers of 2. So I'm very sure this one is running for logarithmic base 2n, because I'm reducing it in powers of 2s. Okay. And then this while loop is being run to figure out the largest 3, the largest power of 2, which is multiplied with this 3, that can be removed. correct? And again, it starts from 1, 2, 3, and the maximum it will go is till 31, because 2 to the power 31 is like a huge number. That's the maximum I can do. So again, this is going in terms of logarithmic calculations, okay? So can I say the overall time complexity will be logarithmic base to n into logarithmic base to n, which is logarithmic base to n square, and the space complexity will be big of 1. Again, one thing, this is not an exact time complexity. Depending on the dividend, depending on the devices, it might be very small as well, okay? So this is something like an approximate measurement of the time complexity. So before I wrap up this video, let's talk about the overflows and the small note which is added in the lead code problem statement. Assume we are dealing with an environment that could only store integers within 32-bit integer range. And if you look at my code, I'm using long. Before I move on to the explanation why am I using long, when it is clearly stated that we're dealing with an environment that could only store 32-bit. This is lead code number 29, which means this problem was set probably 5, 6, 7 years down the line. And they didn't think about it or they didn't modify it. Why do I say this? If I take the dividend to be minus 2 to the power 31, and there is a line where I'm writing equal to absolute. So when you do an absolute of minus 2 to the power 31, you will get 2 to the power 31, and this cannot be stored in an integer because integer can only store this much. So either you write a bunch of if else, and that will make the code clumsier, or you have other option of using long. And I'll prefer using a data type which is there in the system. Please explain this to the interviewer if he's asking. He will not ask in most of the cases because when they give you this problem, what they're looking for is your understanding of break. Because if they're giving you this problem, they're not looking for overflow scenarios. What they're looking for is, can you break 7 down into powers of 2s and then can you solve it? That's what they're looking for. So that will be it for this one. So if you're still not watching and if you've understood everything, please do consider giving us a like.
तो हाईएस्ट पावर ऑफ 2 हटाना है इसमें से. ना जिया जिंदगी एक पल भी. बिग ऑफ 1 में तो नहीं हो पाएगा. देखो अगर डिविडेंड डिवाइजर के इक्वल हो तो रिटर्न कर देना है हमें 1. एक साइन वाला ले लेंगे क्योंकि सारा हम पहले ऑपरेशन पॉजिटिव पे ही करेंगे, भले नेगेटिव कुछ दिया उसको ये बना देंगे. जो तू नहीं तो ऐसा है चेहरा के जिसकी खूबसूरत मांद पड़े हो, ऐसा है किया जो बहना ना चाहे. जो तू नहीं तो ऐसा है मेरा किया के जिसकी खूबसूरत मांद पड़े हो. दरिया मेरे दिल का ये बहकाना. जो तू नहीं तो ऐसा है चेहरा के जिसके खूबसूरत मांग पड़े हो. क्वेश्चन एन और डी ले लिया, ठीक है. क्वेश्चन को 0 ले लिया, ठीक है. फिर क्या किया हमने, काउंट को 0 ले लिया. अब इसमें सबसे बड़ा नंबर हटाना है हमें 2 की पावर का। तो हम क्या कर रहे हैं, n ग्रेटर देन इक्वल टू, जब तक मेरा d लेफ्ट शिफ्ट d इंटू लेफ्ट शिफ्ट आना है ना, इसको यहाँ पे एक ब्रैकेट बना देंगे। ठीक है, अब d लेफ्ट शिफ्ट काउंट +1। ठीक है, अब यहाँ से जब तक ये नहीं हो जाता बढ़ाते जाएंगे। और कोशेंट क्या हो जाएगा मेरा, काउंट। यस, करेक्ट। और n माइनस इक्वल टू d इंटू सी एन टी। करेक्ट, बराबर। अब ये हो गया अपना खत्म सवाल। अब आप एक केसेस हैंडल करने, इफ, पर इन्होंने अपडेट क्यों नहीं करा है जब रिटर्न ही लॉन्ग लॉन्ग में कर रहे हैं, तो 31 का तो सवाल आता ही नहीं है कुछ भी। घुटनों है तो ऐसा है। हैं, इसकी वैंडिश की छटकी लड़की, बुद्धि लड़की, फैंसी सी थी। अगर लॉन्ग लॉन्ग में कन्वर्ट कर दिया है तो क्या दिक्कत है? हैं, लॉन्ग लॉन्ग में कन्वर्ट कर दिया तो दिक्कत क्या है? तो फिर छटकी लड़की फैंसी सी, मेरी बहन भी। अच्छा, साइन भी तो देखना है, साइन भी तो देखना है। साइन, ह, 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 यू यू ओ टी आई एन टी। सी, सिस्टम पूरा। पर ये लॉगरिथमिक, ये बिग ऑफ 1 क्यों दिया है इन्होंने वहां पे? लॉगरिथमिक में हो रहा है ये तो अपना, है ना? लॉगरिथमिक में ही हो रहा है।
Integer range. And if you look at my code, I'm using long. Before I move on to the explanation why am I using long, when it's clearly stated that we're dealing with an environment that could only store 32-bit. This is lead code number 29, which means this problem was set probably 5, 6, 7 years down the line. And they didn't think about it or they didn't modify it. Why do I say this? If I take the dividend to be minus 2 to the power 31, and there is a line where I'm writing equal to absolute. So when you do an absolute of minus 2 to the power 31, you will get 2 to the power 31. And this cannot be stored in an integer because integer can only store this much. So either you write a bunch of ifs, and that will make the code clumsier,
log
or you have
base
other
to
options
n
which
है।
is long. And I will prefer using a data type which is there in the system. Please explain this to the interviewer if he's asking. He will not ask in most of the cases because when they give you this problem, what they're looking for is your understanding of break. Because if they're giving you this problem, they're not looking for overflow scenarios. What they're looking for is, can you break 7 down into powers of 2s and then can you solve it? That's what they're looking for. So that will be it for this one. So if you're still not watching and if you've understood everything, please do consider giving us a like and if you're new to our channel, do consider subscribe as well. Okay. So this is a power of 2 which is multiplied with this 3 that can be a while loop. So we know something into something will be the time complexity. First of all, this is getting reduced like 22, 10, and then so on. And what are we reducing? 22, we wrote it as 3 into 7, and the 7 was 4 plus 2 plus 1. That's a logarithmic representation of 7, like in powers of 2. So I'm very sure this one is running for logarithmic base 1 because I'm reducing it in powers of 2s. Okay. And then this while loop is being run to figure out the largest 3, the largest power of 2, which is multiplied with this 3 that can be removed, correct? And again, it starts from 1, 2, 3, and the maximum it will go is still 31. Because 2 to the power 31 is like a huge number. That's the maximum I can do. So again, this is going in terms of logarithmic calculations. Okay. So can I say the overall time complexity will be logarithmic base 2n into logarithmic base 2n, which is logarithmic base 2n square. And the space complexity will be big of 1. Again, one thing, this is not an exact time complexity. Depending on the dividend, depending on the divisor, this might.
Okay, 145 solved. Okay. तूने ही तो ऐसा है, चेहरा के जिसके खूबसूरत मांग पर। चाओ। बंदी लड़की फैन जैसी थी। मेरी फैन भी थी। पापा कहते जॉली। मैं तो खा गया मीठे रैपर अर्ली इन द मॉर्निंग। क्या ढूंढना है? फाइंड द स्क्वायर रूट। टाटो टूटू। स्क्वायर रूट ढूंढना है। Apuma, Apuma city, I'm a map, I'm a rolling like a Rambo. Apuma, Apuma city, I'm a map, I'm a rolling like a Rambo. Square root. लॉगरिथमिक भी दे देना, ठीक है दे दिया। चलो 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 चलो। Apuma city, I'm a map, I'm a rolling like a Rambo. बंदी यदि माइंडर लैंग्वेज मुंह से निकले। int d is equal to 1 while cnt is equal to 1. City, I'm a map, I'm a rolling like a Rambo. माइंडर लैंग्वेज उससे निकले। लोनी जायरेड है इसको। अरे बाहर रख तू चेस्ट को। नाड़ बीच के खींच को। की अंदीशी चटकी लड़की बूढ़ी बोली फैंसी सी। मेरी फैन नहीं थी। Forward return the floor value. Floor value of any number is the greatest one. ठीक है ठीक है ठीक है। स्क्वायर कैसे निकालते भाई? हाउ टू डू स्क्वायर bitwise. Rule में study map rule भी लग कर रहा है 2 into 4 n by 2 plus 1 so निगलन पावर है ये CDM map rule लग कर रहा है वाओ मेरे को देखो भाई प्रीवियस सबमिशन देखो मेरा यूज सर्चिंग एल्गोरिथम अबे देखो बात ऐसी है कि ये तो मैं ऐसे कर दूं पर यहाँ पे कुछ तो लिखा था मुझे यूज नहीं करना है सिक्योरिटी स्मार्ट किड्स हेलो स्मार्ट किड्स स्मार्ट किड्स हो भाई आप तो देखो ऐसे तो हो गया हमारा प्रॉब्लम पर सर्चिंग एल्गोरिथम लगाना और मैंने लॉगिन ही लगाया इसमें लॉगिन ही लग रहा है पर फिर भी जस्ट इन केस विदाउट सिक्योरिटी बाइनरी से
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So we will be continuing with our binary search playlist, which is the part of the Strivers A to Z DSA course. In case you haven't checked it out yet, there's a link in the description. Please make sure you check it out. So we will be starting off with the pattern binary search on answers. And the first problem that we will be solving is find the square root of an integer. Now what does the problem state? The problem states that you're given an integer. Imagine I'm giving you the integer as 25. So the moment you say square root of 25, the value is 5. If I tell you n is 30, the square root of 30 is 5 point something. So you will have to return the integer value or the floor value of it. If I give you the value as n equal to 35, you take square root of 35, it is again 5 point something, which is close to 6, but I will ask the floor value. If I say n is 36, then you say square root of 36 is 6, and then you return 6. So I want you to return me the floor of the square root of a given integer. So how do you solve this particular problem? One of the easiest ways is to probably use the function mat.square root in Java or the square root function in C++, and that will give us the answer. But we are going to learn the binary search method. Why? Because this is going to help us solve a lot of problems. So what is the naive way, like the linear search way? The linear search way, imagine I give you n is 25. The linear search will be, I'll take 1, I'll do 1 into 1, that's 1, that's not 25. I take 2, 2 into 2, that's 4, that's not 25. I take 3, 3 into 3, that's 9. That's not 25. I take 4, 4 into 4, 16. That's not 25. I take 5, 5 into 5, that's 25. And I say, yes, this can be a possible answer. Or what if it was something like, just imagine, instead of a complete value, it was something like 28. In that case, you'd have gone with 1, 2, 3, 4, 5. And whenever you had 6, 6 into 6 would have been 36. And the value 36 would have exceeded 28. So the possible answer would have been 5. So we can linearly traverse, right? So what's the code for this? If I have to write the code, can I say the code will be for I equal to 1, I lesser than top way before that, but we can go to here. If I'm going to the else part, what does it mean? It means it's greater than n. So I'll say break. Can I do this? I can. So this will be working, right? So if you take this particular example, 28, it goes for 1, 2, 3, 4, 5, and the last value answer will be storing is 5. And after that, whenever I becomes 6, this condition is false. Hence, the break statement will be executed and it goes out of the for loop. So eventually, the answer will be stored as 5, and that is our answer. So look at the pattern. Why did we stop at 5? I'm saying 1 might be an answer. I'm not sure. 2 might be an answer, I'm not sure. 3 might be an answer, I'm not sure. 4 might be an answer, I'm not sure. 5 might be an answer, I'm not sure. 6 is not an answer. 6 is definitely not an answer. Why? Because 6 into 6 is 36, and the possible, like the value that is given to us is 28. So 6 is definitely not going to be an answer. And I'm very much sure that anything greater than 6, which is 7, 8, 9, will never be an answer. Will never be an answer, because if you take 6, it's already exceeding. If I take anything greater than 6, that will also exceed. Very much sure. Thereby, I surely know anything after 6 will never be an answer. Whereas all of these can be my answer, and I take always the maximum value. I take always the maximum value. So whenever you have such cases where till a certain point the answers are possible, and after a certain point the answer is not possible, we can always apply binary search on that. Remember this. Why? You will understand as I show you the example. So we're looking for n equal to 28's square root. Can I keep the low as 1? Like just hypothetically, I'm not doing a binary search on an array. I'm trying to find an answer. So what can be the minimalistic answer? 1. And what can be the highest answer? That's definitely 28. Nothing bigger than 28 can be my answer. Like I'm not doing 28 into 28. I'm just thinking out of the box. Nothing bigger than 28 can be my answer for sure. So I'm keeping low as 1, and we are keeping high as 28. So if I go across and take the mid value, what is the mid value? 1 plus 28, that's 29 by 2. That's 14.5. That's 14 in integer. So I can write 14. Now if I have to check, 14 into 14 is actually greater than 28. 14 into 14 is actually greater than 28. So thereby, can I say if 14 is not my answer, then I'm very much sure 15, 16, and everything till 28 will never be my answer? Can I surely say this? I can. I can surely say this. Thereby, what I do is I eliminate everything on the right. Why? Just because of this reason. If I'm standing at a not possible stuff, everything on the right will also be not possible. So why do I consider the right portion? So what I do is I eliminate the right portion. And the moment I eliminate, the high will be coming across to 13. The high will be coming across to 13. So we're just playing around with numbers. I'm not taking any array. So high is 13. Let me write that. So the high is 13. This time where will the mid point to? Can I say the mid will point to 13 plus 1? That is 14 by 2, 7. Obviously, will 7 be my answer? 7 into 7 is actually greater than 28. So 7 also cannot be my answer. Again, I'm standing at a not possible. So can I say everything to the right of 7 is also not possible? Obviously no. Thereby, I say everything can be cancelled. Hence, this high will move to 6, which is one place before mid. Simple binary search, eliminating the right half. High will be 6. Perfect. What is the mid this time? 1 plus 6 is 7. 7 by 2 is 3.5. So thereby the mid will be 3. This time, 3 into 3 is not greater than 28. So I'm saying maybe this 3 is an answer. Why? Because 3 into 3 is lesser than equal to 28. I'm not sure that this is an answer or not, but this might be my answer. Like probably I'm standing somewhere here. So this I'm standing in this possible section. Probably 3 might be my answer. Why? Because 3 into 3 is lesser than 28. So it's not the square root, but it might be my answer. So I'm saying, hey answer, can you store 3? Hey answer, can you store 3? He says, okay, let me store 3. Now tell me
या
one thing.
फिर लो को
Do I
यही
go
कर
on the
देंगे
left? Will that make sense? Or shall I go on the right to find a bigger number? Because if I've got 3,
Yes.
obviously 2 will never be my answer. Obviously 1 will never be my answer. So can I surely say anything on the left will never be my answer? I've taken the assumption of 3 being my answer, but anything on the left will never be my answer. I can. Thereby, the low will go to 4. Perfect. Let's take the low to 4. So the moment I take the low to 4, this time the mid will be low plus I, 4 plus 6, that's 10, 10 by 2 is 5. So I have 5. The moment I have 5, what do I check? I again check the same thing. 5 into 5, lesser than equal to 28, and I find, yes, it is. 5 into 5 is lesser than 28. I say answer, you got someone better. Please replace yourself. Because I'm looking for a square root, and I'm going to the right to find the biggest value that is lesser than equal to 28. I've got 5. So I know one thing, probably I'm standing somewhere here, and I can surely say, anything to the left, I don't need it. I need the biggest value that is close to that value when I do a multiplication. Thereby, I say, can you please eliminate and take the low to this portion, which is one place ahead of mid, that is at high. Thereby, we are at 6, and the low points here, and the high points here, and the mid also points here. So currently we're standing here. Point to note, we're standing at a single value, and this time when I do 6 into 6, that's greater than 28. So 6 cannot be my answer. 6 cannot be my answer. And if it cannot be my answer, I say I'm standing on this portion, thereby the right portion will be eliminated. And if the right portion is eliminated, the high will always move one step back. If the right portion, remember this, if not possible, the right portion is eliminated. If possible, the left portion will be eliminated because I'm looking for the possible answers. Thereby, what happens? I take the high to 5, and this is where we end. This is where the binary search will end. So if you remember in the initial lectures I told you one thing. As of now, you can play with this answer and you can always store your binary search answer. But eventually as you go through, you'll understand that one of the high or one of the low will always be pointing to the answer. So in this case, you can see that this variable high is actually pointing to your answer, that is 5. And why did that happen? The sole reason is, since you're trying to, I'll just write it for you. Since you're trying to eliminate, and this is the not possible zone. So you're trying to move on this direction. And that's why the high will cross the low. And when you're trying, because high was here initially at a not possible place, and the low was at a possible place. So since you're eliminating, thereby the low will always move towards right, and the high will always move towards left. Hence, the low ends up pointing. The low ends up pointing at the first place, where it is not possible, and the high ends up pointing at the first place which is possible. So to repeat, the low was at starting pointing to a place where it is possible. The high was pointing to a place where it was not possible. And they're trying to move, and on moving, they'll come to a place where it is not possible. This will come to a place where it is possible. Hence, the high will always be storing your answer. So in order to understand this much better, what I'll tell you is take some more examples and take a pen and paper and try to do the.
ये तो चीज तो वही हुआ ना लाला, हम ये करे या वो करे, है ना? कि हमने क्या किया, int I, int low, int j, ठीक है, y I whole picture if हाई एच, ये एल है मेरा। ओहो हो, पूरा बतंगड़ बना दिया। अब सही है, बतंगड़। इश्क गुलाबी बादलों फंस रहा है, नहीं चाहत तने नाम तेरा
the trial and I'll eventually understand how does the binary search work in this case. So we have pretty much done this stuff. Can I say that this line was the linear search, and because of this line, the complexity was near about big O of n, near about big O of n. But this concept will now be replaced with binary search because I'm not going through the iterative stuff. Instead of that, what I'm doing is I'm saying, hey, listen, you're given a number, thereby the low will be 1, the high will be n in this case, and we can keep the answer so that you can understand it in a much better way. I can say while low lesser than equal to high, and inside that I can write mid equal to low plus high by 2, and after that, can you say if mid cross mid is lesser than equal to the n, then your possible answer can be this mid, can be, but I'm looking for a bigger value every time because this might be it, but maybe someone else can be. So I will always go and eliminate the left half and I'll move on the right. Perfect. Or else, if this is not possible, this is not an answer, look for smaller values. Look for smaller values. That is, eliminate the right half. Quite simple. Once you're done with this, either you can return the high or you can return the answer. That is your choice. You can return either of them and that will work. So remember at the beginning of this lecture, I told you that we will be doing this pattern, binary search on answers. So remember one thing, whatever problem you will see in the future on binary search and answers, they will always be focused on this thing that you always know the range of answers. Like in this question, I was being asked to find the square root of n, and it was being asked floor of that square root of n. That was the question. If I have to modify the problem statement, it will be find the maximum integer, find the maximum number or integer, which on squaring is lesser than n. Can I say this? Because 5 was the maximum integer, which on squaring was lesser than equal to 28, because 6 on squaring was greater than 28, 4 was also a possible answer, but I was being asked to figure out the max integer. So across all the questions on binary search, on answers, you'll be asked to find minimum possible integer or maximum possible integer, which can be your answer. So problem statements will vary, and we will be solving a bunch of those in the upcoming lectures, but remember, whenever you see something like min or max, find out the minimum integer, find out the maximum integer, and if in a question you're sure that the answer, like in this case, the answer was always between 1 and n, if you're sure about the answer range and they're asking you to find the minimum and maximum in that answer range, always binary search, always. And the pattern will be very simple. You do the binary search, and this one is known as the check box. This is the check, because this was the question. This was the question check condition. The question was stating maximum integer whose squaring is less than equal to n, and that's what I did. The check condition. Binary search under the check condition. Got it? Let's quickly jump into the code editor. By the way, you can find out the problem link in the description. So the first thing to observe is I'm taking long.
Okay, we are done. Oh, it's a year 146. Care of the number. Power set. Given a string S, find the possible non-empty subsequent string. है, ये तो कर चुके हैं हम, ये थोड़ी मीनिंग है। आओ ग्रीडी पे आ गए। तुडु तो तुडुडु तुडु तु तुडुडु तुडु तु तुडु तु तुडु तुडुडु You are given timing of end meeting in form of start and where start is the meeting I and the end I is the finish order. Return the maximum hour of meeting that can be accommodated in a single meeting hour. And only one meeting can be held in a meeting hour. Start time of the children meeting can be equal to the end time. Can't be. Maximum four meeting can be held with one start and end time. 1 to 2, 3 to 4. So, बादलों का चुरा है तेरे गए हैं मैं आशिकी मेरी चाहतों चले ना तेरा maximum four meeting can be held with given start and end time. The meetings are 1, 2, 3, 4, 5, 7, 8, 9. मेरा ना दिमाग में बार बार वो सब सीक्वेंस वाला खा रहा है बस ऐसे ऐसे अधूरा है कतरा कतरा इश्क गुलाबी बादलों का चूरा है कर गए कर गए कितने आशिक मेरी चाह तो चले तेरा होठ लगा इश्क जो ही पूरा है ले आई तेरी याद तेरी सादगी हमें थोड़ा इस प्यार में जलेगी हमें आपके तो नाम में भरेगी लाई हो गई तेरे तुझे तो लाई मोहब्बत लाई मोहब्बत। अभी ये देखा तुमने इधर पे सेट है भेजा ही रेज इधर वो वेक्टर है। वो हप हप मारने आ रहे मैटरो में। घुमाता ला घुमा में मैटेडोर मैटेरो में। कॉन्ट्रैक्ट से कैंसिल हो गए। ऐसी रात रात ये है ही नहीं ना। ऐसा भी तो हो सकता है। ए आया ए ऐड हो गया। आगे चले गए। बी आया आगे चले गए। सी आया आगे चले गए। सी आया सी लिया नहीं आगे चले गए। तो ए भी आना चाहिए। पूरा है पर गए हाँ मैं आशिक तेरी चाह या फिर तेरी सादगी मैं थोड़ा आओ 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 आओ, हम क्या करेंगे? तू के बातों ओ मैं आ गई। लोगों ने दिए हैं मुझे बड़े बड़े नजराने, मैं तेरे लिए लाई हूँ दिल मेरा। ओ मेरे सजना लो, मैं मैं गई। इसका रहा हूँ। Got it. Got it. 2 है मैक्स। तोरारो रोता तोरातो, तोरारो रोता तोरातो, तोरारो रोता तोरातो। मैक्स है 2, तो 2 से बड़ा होगा कोई तो ही आएगा, तो 2 से बड़ा कौन है? 3 है स्टार्टिंग पॉइंट। और 4 है, 4 के बाद इसने 6 देखा, 6 का स्टार्टिंग पॉइंट 4 से बड़ा नहीं, फिर ये आ गया है। एक तो है मैक्स किस पे रहेगा, और एक है आइटरेटर। ठीक है, समझ गया मैं, समझ गया हूँ। नाम तेरा होठ लगा दे, बादलों का छुरा है, ले आई तेरी। स्टार्ट एंड ऐसा कुछ नाम लिख देते हैं ना, एक इंटीजर एन बना देते हैं जो कि स्टार्ट डॉट साइज बताएगा। अपने को थोड़ा इजी पड़ेगा रे। वो भी जगह थूकना, बैठ इसके कुश्ती में। सही है ना? सही नहीं है, अब सही है। शॉर्ट। इश्क वही पूरा है, कर गए हैं कितने आशिक, नहीं चाह तो चले नाम तेरा। आ ना 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 अब तेरी सादगी। ते- तेरा मेरा रिश्ता पुराना, तेरा मेरा रिश्ता पुराना, आंखें हैं सांसें चुभन रही, कर देना ना ना पता, तेरा मेरा रिश्ता पुराना, ओ तेरा मेरा रिश्ता पुराना, आते हैं मेरी। क्या ये सही है? हम सॉर्ट कर रहे हैं। भाई आपकी स्किल्स क्या क्या है? आ, मतलब किस चीज को लेकर स्किल्स, क्या किस चीज में स्किल्स? स्किल्स म्हणजे मतलब ऐसा टेक्निकल स्किल्स नहीं पूछ रहे हो क्या? क्या टेक्निकल स्किल्स या एक्स्ट्रा करिकुलर स्किल्स? कोडिंग की स्किल्स की पूछ रहे हो? मतलब टेक्निकल स्किल्स पूछ रहे हो? क्या पूछ रहे हो? क्योंकि ना मैं जानू ना तू जाने कैसा है ये मौसम, कोई न जाने कहाँ से ये फिजा आई, हटाए काली क्यों चाई। टेक्निकल स्किल्स। वफा हो गए हम। आ, पहले स्कोर अपडेट करके मेरा 147 सवाल सॉल्व। हाँ, तो टेक्निकल स्किल्स में क्या आता है? मेरे को मॉन्स्टैक आता है, मैंने इंटर्न डॉट नेट में कर रखी है तो वो मेरे को आता है थोड़ा बहुत। फिर एंगुलर आता है, फिर डीएसए कर रहा हूँ, इससे सीपीपी आता है। फिर वो अपने सीएस फंडामेंटल तो है ही, ओएस सी एन डीबीएमएस बस। बाकी हाँ एसक्यूएल भी है, एसक्यूएल आता है, इतना है। तेरा मेरा रिश्ता पुराना, आंखें नम मेरी, तेरा मेरा रिश्ता पुराना। मेरे होठों से धुआंधार निकलती है जो गोली ऐसे ऐसे तो गीत में गोली बाकी सब फर्स्ट क्लास है, बाकी सब फर्स्ट क्लास है, हाँ कसम से बाकी सब फर्स्ट क्लास है। आओ 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 आओ, ये हमने पैर बना लिया, ये हमने डेडलाइन और साइंस को एंड लिख दिया, जॉब्स और प्रॉफिट को ये कर दिया, पुश बैक कर दिया डेडलाइन में, फिर सॉर्ट कर दिया बिगिन से एंड में डेडलाइन के बेसिस पे, फिर एक प्रायोरिटी क्यू बना दिया, इंडेक्स बना दिया, फिर बीपी ऑफ इंडेक्स मतलब सबसे छोटा वाला ये आएगा, और आओ ठीक है, इंडेक्स फर्स्ट से सबसे बड़ा वाला आएगा सर, सबसे बड़ा वाला आएगा प्रॉफिट। अगर इंडेक्स जीरो है, इंडेक्स इंडेक्स और आ रही है तो प्रायोरिटी की मैं पुश कर दूंगा, इंडेक्स माइनस माइनस कर दूंगा, आई मेरा मैं लाख जतन कर हारे, लाख जतन कर हार रहे मुरासैया, मुसबुला मुरासैया, मुसबुला मैं लाख जतन करूं हारे, लाख जतन करूं हार रहे मुरासैया, मुसबुला मैंने तिहारी राह लिहाजे नैनन को ना 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 से मुझसे बोले ना तो उदास से। बैंड की डिग्री इसकी एनडीजी चटकी लड़की फैंसी मेरी फैमिली चटकी लड़की फैंसी, ठीक है, इंडेक्स से ये चलेगा, ठीक है, इंडेक्स है मेरा 4, आई ग्रेटर देन इक्वल टू, क्या मेरे इंडेक्स ग्रेटर देन 0 है? हाँ है। और क्या मेरा आई बीपी ऑफ वो बैंड Party, party, it's party, it's party. Yes, 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 इक्वल है तो प्रायोरिटी क्यू में 20 डाल दिया, चलो 20 डाल इंडेक्स माइनस माइनस किया 2, इंडेक्स हो गया मेरा 2। हाँ ग्रेटर देन 0 है, वीपी ऑफ 2 का फर्स्ट, वीपी ऑफ 2 का फर्स्ट ना, नहीं है। वीपी ऑफ इंडेक्स माइनस माइनस कर दिया कि तो क्या मेरा इसके बराबर है, नहीं है, नहीं है, नहीं। तो अंदर नहीं जाएगा है ना। इंडेक्स ऑफ 2, इंडेक्स ऑफ 2 का फर्स्ट यानी डेडलाइन ही पूछना है, नहीं नहीं जाएगा, फॉलो किया जाएगा। जॉब्स प्लस प्लस प्रॉफिट में बेचा जाएगा और ये एल दिया जाएगा। ठीक है। अब आई का वैल्यू है मेरा 3 और इंडेक्स का वैल्यू था मेरा 2, जो कि को लाया है। आई का वैल्यू है फर्स्ट, तो अब आई का वैल्यू 3 होगा। ठीक है, इंडेक्स का वैल्यू 2 है और क्या मेरा 3 इक्वल टू वीपी ऑफ 2 का फर्स्ट है, नहीं नहीं, तो आई का वैल्यू 2 होगा, फिर आई का वैल्यू 1 होगा। फिर हम देखेंगे क्या मेरा 1 के वैल्यू वीपी ऑफ 2 है है पुश पुश पुश, तो 40, 30 और 10 आ जाएगा और इसमें से 40 ऑफ हो जाएगा। तो हम वही देख रहे हैं कि मेरा जो इंडेक्स है वो मेरा इसका इंडेक्स है, और देखेंगे। तो आई जो है 4 है, आई मेरा बीपीएफ इंडेक्स के बराबर है 3। सही है। मैंने तिहारी राह निहारी। Hard Huffman coding encoding. Given a string as of distinct character of size and their corresponding frequency f. Character s of I and s of I has frequency. Given a string of distinct character of size n and their corresponding frequency f of a. Character s of I has frequency f of I. The task is to build the Huffman tree print of all Huffman code in pre-order traversal of a tree. Dumtana na 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 dumtana na 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 dumtana 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 dumtana. तुमसे मेरी लगने लगी। ये क्या कहना चाह रहा है भाई? 100 क्या है, 0 क्या है? अरे you should build the Huffman preprint of all the Huffman code in pre-order। ये तो आता ही नहीं है, ये तो आता ही नहीं है भाई जी। 957. A क्या ना ब्रो, ना ब्रो, नहीं आता। हाफमैन एनकोडिंग नहीं आता, पता ही नहीं है क्या होता है।
Hi, the topic is Huffman coding. Huffman coding is a compression technique. It is used for reducing the size of data or message. Suppose you want to store the data in a file, so you can store the data in compressed form to reduce the size of a file. When the data is sent over a network, data can be compressed and sent to reduce the cost of transmission. In this video, I am going to explain you if a normal message is sent, what will be the cost, and what is the fixed size encoding, then what is variable size encoding, that is Huffman coding. Now let us study the problem. I have a message here. Now this message I want to store it in a file, or I want to we are live. Hi everyone, welcome back to Geeks for Geeks practice. Today we will discuss the problem, that is Huffman coding, which was problem of the day for 17th of December 2021. So please quickly give me a +1 in the chat if I am audible and my screen is visible to everyone, and then after some time we'll start with this session. And also let me know in the comments how many of you have solved this problem, so that I'm also aware about what are the difficulties that you faced, and what were the methods that you applied for solving this problem. So all those who have joined this stream and can hear me clearly, please quickly give a +1 in the chat. Right. So I'll just wait for a couple of minutes for everyone else to join in, and then immediately we'll start with the session. So all those who have joined, please quickly give me a +1 in the chat.
Let me try. Ankur, the proposal needs to be signed.
Now? But we don't have a laptop. Don't stress. I can do it on the go. With Acrobat, it's all sorted.
And immediately we'll begin with today's session. And also let me know how are you? Chirag, I'm good. How are you? I'm doing fine. How many problems are you practicing these days? So I can see that 3 people are watching. I'll just wait for 1 or 2 more minutes for everyone else to join, because this is going to be a good question that we'll be discussing. So that is why I just want everyone to join in, so that there is no break or that nobody misses the problem statement and the concept. Because once I'll be explaining, then it is a good concept to explain. And for this problem, talking about this problem, one more thing that I want to tell you for this problem is the companies that it has been asked. So this problem, that is Huffman encoding, has been asked in Amazon, Morgan Stanley, Samsung, United Health Group, and Microsoft. So you can see that this problem has been asked in a lot of good companies as well, right? So shall we start? If everyone agrees that we should start, so please quickly give a +1 in the chat, or write yes in the chat, so that we can begin ahead. Okay. Right. So let's shall we start? Okay, let's start with the problem statement. So the problem name is Huffman encoding, and this problem says that this problem has been asked in a lot of product-based companies. The problem says that you have been given a string S of distinct characters, right? All those who have joined the chat, please give a +1 in the chat, so that I know that everything is working fine. Given you have been given a string S of distinct characters of size n, so you have been given a string S which is containing distinct characters of size n, right? The string size is n, and then corresponding frequency. So you have been given the characters and you have been given the frequency as well, right? So for the character SI, the frequency is FI, right? For the ith character SI, for the ith character, that is SI, the frequency of that character will be FI, right? And your task is to build the Huffman tree and then print all the Huffman codes in the pre-ordered traversal of the tree. Okay, is the basic problem statement clear to everyone? You have been given a string, and that string size is n. For the ith character, the character at the ith position will be SI, and the frequency of that particular character at the ith position will be FI, right? And your task is to build the Huffman tree. That is, you have to print all the codes for all the Huffman codes in the pre-ordered traversal for every node, right? So I'll be telling you what is the Huffman tree and how it can be solved in a greedy manner, and everything based on that, why we use it as well. But first of all, let me know, is this much part clear to everyone? Just quickly let me know. Okay, right. So moving on, shall I start? Okay, right. So starting with the question now. So what is Huffman coding first of all? Why do we need it? First of all, let's say that you have been given a string. Okay, let's say you have been given a string.
you have been given a string, right, S, and in that string what happens is you have been given some string, right, you have been given some string which is having some characters. So in this string there will be frequency of each character, right? So that is why what will happen is, let's say there is a character A, and that character A is having a frequency of A is equal to what, let's say A is equal to 5, then B is equal to 2, and then C is equal to 3, right? So if this is the frequency that each character is having, then in that case what we have to do is we have to encode these characters, right? We have hi Vanshika, so we have to do what in this problem, we have to encode these characters, right? So let's take a bigger example for that case. Let me take the example. So let's say that you have A is equal to 5, that is the number of occurrences of A in the string. The number of occurrences of A in the string is 5, B is 9, then C is 12, and then D is 13, and E is let's say 16, right? And let's say the frequency of F, that is the number of occurrences of F in the given string, is let's say 45, right? So in this case, what will happen is, if someone, let's say someone asks you to represent this string, right? I think that a lot of people have joined, so just to repeat the question, in this problem you have to do Huffman coding. I'll be telling you with this test case as well, okay? So what you have been given is you have been given A, B, C, D, and E, and F. So that is for each character you have been given its frequency in the given string S, so it will be having some A, some B, some C, right? Some D up to left, okay? It will be having these characters. Now you have to do what? You have to represent this given string in the form. You have to represent all those who have just joined. Please like the video and comment +1 so that I know that everything is working fine for all of you as well, okay? So what you will be given the frequency of the characters and you have to encode this string, right? So for encoding, what we do? Let's say we were given only A and B, right? And there were some occurrences of A and there were some occurrences of B. So in that case, what I could have done is I could have made A as 0, 0. I could have represented A with a 0, 0 since I have to do the encoding part. That is compression. So data compression, okay, data encoding. So B is what? B is 0, 1, right? So there were only two characters. Can I say that I could have represented them using 2 bits? Can I say that for each character I could have represented them using 2 bits? And let's say the number frequency A was occurring 4 times, right? A was occurring 4 times, and let's say B was occurring 3 times, right? So in this case, the total size that it could have taken was 4 into 2, that is 6, and for this it would have been 3 into 2, 4 into 2, that is 8, and 3 into 2, that is 6. So the total size would have been 14, right? 14 bits total, right? Is this much part clear to everyone, right? I hope that this basic part is clear to all of you. Now there arises a situation such that what will happen? If let's say I had 3 characters, right? If I had 3 characters, then also I could have done it, right? If I had 4 characters, then also I could have done it, because for A it would have been 0, 0, for B it could have been 0, 1, and for C it could have been 1, 0, and for D it could have been 1, 1, right? So still I could have represented them. Each character could have been represented using 2 frequencies, and the total size taken by that particular character would have been 2 into the number of bits, that is 2 into the frequency of each character, right? The ith character, and in the end I could have summed up. But now let's say that I have a bigger situation. So what I could do instead is, let's say I have a lot of characters, okay? Or let's say I have the characters from A to F. Let's say I have the characters now from A to F. If this is the case that I'm having characters from A to F, in this case, can I say that the total number of such type of characters, the total number of characters that I can have is nothing but 128. The total number of characters that I have is 128. This is very basic part, right? So can I say that if I represent them in terms of ASCII, so that is nothing but 0 to 127, right? And can I say that each character, since the highest number is 128, so each can be represented in 8 bits. Can I say this? Yes, I can say this, right? I can say this, that each character can be represented in 8 bits, because the last character, that is the character that is having ASCII code 127, has to be represented using 8 bits, right? So can I say that for all characters I can take 8 bits, right? But let's suppose that total number of characters are 100, right? Let's suppose that there are 100 characters. If there are 100 characters, then in that case, what will be the answer? 8 into 100, right? One character is taking 8 bits. So every character, 100 characters will be taking 800 bits, right? Can I say this? If I have 100 characters of A, B, C, D, E, and F, and if I try to represent each character using 8 bits, right? So can I say that the total bits taken by me will be 800 bits, right? I can say that. I can easily say that, right? Now the question comes that can I reduce this? Yes, I can reduce this. How? I'll be telling you how you can reduce this. So for reducing this, you only need to notice a pattern, and that pattern is basically that you need to check that for each character that you are having here, in this case, each character that you have can be represented using only 3 bits, right? On let's say 3 bits, okay? So how it can be represented using 3 bits? So let's say if the characters that are given to me are from A to, let's say I represent A using 0, 0, 0, I represent B using 0, 0, 1, C using 0, 1, 0, let's say this, or D using anything like this, okay? If I represent these characters like these, like using 3 bits, I can represent all of these characters, because using 3 bits, I have 2 to the power 8, that is 2 to the power 3, right? If I use only 2 bits, then I can represent only 4 characters, right? I can represent only 4 characters, but if I use 3 bits, that is 2 to the power 3, then I can represent 8 characters, right? I can have 8 different type of binary strings, right? So that is what in this question we can do. Earlier we were representing them using 8 bits, but I can also represent them using 3 bits, right? Because using 3 bits, I can make 8 unique characters, right? This is a property, right? Everyone knows that. Now coming to this part, how we will do this. So for this, what we need to do is we need to observe one thing. One thing that we need to observe is that if I represent them like that, if I represent A using 3 bits, right, that is let's say 0, 0, 0, and if I represent B using 0, 0, 1, and like this, okay, it is also taking 3 bits. So for each character I'm taking how many bits? For each character I will be taking a total of how many bits? I'll be taking 3 bits, right? So there are 100 characters, so I multiply that by 3. So now if I represent each character using 3 bits, so overall I'll be taking 300 bits, right? I'll be taking 300 bits. If I was representing each character using 8 bits, then it was coming out to be what? It was coming out to be 800. For 100 characters, it was coming out to be 800, right? 800 bits. But if I represent each character using 3 bits, if I can uniquely represent them as I told you, so can I say that I can represent them using 300 bits, right? Is this much part clear to everyone? I hope that it is clear to everyone. Is this much part clear to everyone? Please quickly let me know in the chat. Is this much part clear to everyone? Right. Perfect. Now can I say that I can represent them using 300 bits? Yes, I can say that, right? But I could have represented them using 800 bits, but it took a lot of size. And if the data size is large, then there's a problem in terms of space as well as in terms of data transfer. If the size is large, then the data transfer rate is slower, right? So can we try to optimize it? Yes, we try to optimize it using 3 characters. We try to represent A to F using 3 bits for each, because I can make 8 different characters, right? So I can easily represent A, B, C up till F, right? So I can use 300 characters, but 300 bits, right? But can I reduce this? Further? That is the task that lies ahead of me. Can I try to reduce this number of bits more, right? How can I do that? And for doing that, I'll be using what? I'll be using the concept that is Huffman coding, right? For doing this, what I'll be doing is, I'll be using Huffman coding, okay? Huffman encoding, right? For doing this, that is, earlier we represented it using 800 bits. Now I can say that I can represent them using 300 bits as well. But the task is, the thing is, can we do something better than this 300? Yes, we can do that. How? We can use the concept of Huffman coding, right? And you can see that since we have to minimize the number of bits, that is the size that will take for encoding. So for doing this, what I can easily say is that this is nothing but a greedy algorithm, right? Because I want to optimize my space. I want to minimize the number of bits that I'll be taking overall for all the 100 characters, right? So what I want to say is that let's say you have these characters, right? So Huffman coding is an encoding concept. So how do we know that what we have to do in this problem? So what we do in Huffman coding is that first of all, let me write the frequency for each character. Let's say the frequency for A is 5, the frequency for B is nothing but 9, the frequency of C is let's say 12, the frequency for D is let's say 13, frequency for E is 16, frequency for F is 45. Right? Let's say these are the frequencies that I have taken. Now the task that lies ahead of me is how do I represent them? Can I represent them under 300 weights? That is the task that lies ahead of me. So what I can do is, what we do in this Huffman coding is you put this into a mini, right, and you extract the first two minimum characters. Okay, every time. Why can't you use 200 bits? Because using if you have to represent A, B, C, D, E, and F, right? There are 6 characters, and if you use only 2 bits, then what are the total combinations that you can have? You can have 0 0. Let's say A, B can be 0 1, C can be 1 0, and D can be 1 1, right? How will you represent E and F? For that you need more bits, right? Because how will you represent E and F? Because all the bits that can be made from 4, all the combinations that can be made from 2 bits are done. So how will you represent that? That is the situation. That is the problem that lies ahead of you. That is why you have to use 3 characters. The minimum number of bits that you need to use is 3, right? You could have also used 8 bits for representing 127, but since the characters are A to Z, so that is why we can use that only 3 bits, right? So that is why I'm doing it. Now the question that lies ahead of me, what I do in this Huffman coding, right? So what I'm now trying to tell you is, what is the Huffman encoding? What is the Huffman encoding algorithm, right? What is the algorithm for this? So what we do first of all is, what we do in this problem is, right? What we do is, you first pick the minimum element. You put all this into a mini, right? You put all this in a mini, right? Let me make a data structure for this. Okay, yeah, this will be a mini, right? In this, what you do is, you put all of them in a mini, and after that, you pick the first 2 characters, right? First.
What's up guys, in this video I'm going to share with you how to come up with business ideas that are actually good. Welcome to How to Start a Startup. In this course I'll share
top 2. You pick the top 2 frequencies, right? The characters that are having the top 2 frequencies. So which are the characters? Can I say that character is A is equal to 5 and B is equal to 9? Yes. So what I'll be doing is, I'll be having this, then I'll be creating a node, right? I'll say that there is a node 1 that I created, and that node will be having 5 plus 9 plus 5. That gives us what? That gives us nothing but 14, right? So that gives me 14. So now I have this, I will remove this and this, I'll have this node 14 in me, right? And this node 14, now I'll tell you what I'm doing in terms of diagrams. Basically I'll be trying to make a Huffman tree, right? That is why I'm trying to do this. So what I'll be doing basically is that I'll have pushed this node 14. Now what I'll be doing is basically I'll try to build. So on the left side I'll be having the element with the lower frequency, on the right node I'll be having the element with the high frequency. Okay, so this is the node A, this is the node B, this node is having a frequency of 5, this node is having a frequency of 9. Once I combine these two nodes, so what is the new frequency that I have? There is a new node that I have is node 1, and the frequency for that particular node is what? 14, right? After this, what I'll do is, I check this again. I check this mini heap again. Is this mini heap having at least 2 elements? Yes, it is having at least 2 elements. It is having elements that is greater than 2, right? So I needed 2 elements. So I'll pick now the 2 new minimum elements. I can say that A is done, A is removed, and B is also removed from this mini, right? Now I have what are the next 2 minimum elements? Can I say that the next minimum elements are C and D? Yes, they are. So C is equal to 12 and D is equal to 13, right? These are the next 2 minimum elements. So what I'll do is, I'll make it here. Let's say I have C and I have D. C is having 12 frequency, so I have kept it towards the left. D is having a frequency of 13, so I have kept it towards right. Well, I have to combine these two, so I do that as well. And once I combine them, so the new node will be having a frequency of 25, right? So let me do that. So the new node will be having a frequency that is 25, right? Let me write it in a clear manner. Okay, so the new node is having a frequency of 25 now. Now my C and D are removed, and now this is node 2. This is nothing but node 2, right? This is node 2, and this is having a frequency of 25, right? After this, what I'll do is, after this, these two are done. Now I will check again. Is my mini heap having characters that are greater than is the mini heap size greater than 2? Yes, it is. So what are the next 2 characters? Can I say that the node number 1 and node number 2, can I say that the node number 1 is having a frequency of 14 and this E, the character E, is having a frequency of 16, right? Node 1 is having a frequency of 14 and character E is having a frequency of 16, right? So I can make E here, I can make E towards the right. Then what I can do is, I can join these two, and I'll be making a node 3. Let's name it as N3, right? Node 3, N3. Let's name it as N3 for better clarity, right? So this is nothing but N3. N3 will be having a size of 30. Can I say this? Yes, I can. N3 is having a size of 30. Notice what I'm doing. I'll be telling you why I'm doing this, but first let's try to analyze what is happening here. Okay, so this much part is done. Now you have N3 is having a frequency of 30, right? After this, what you will do is, after this, you can see, what if 2 non-leaf will check again. Is my mini heap having characters that are greater than is the mini heap size greater than 2? Yes, it is. So what are the next 2 characters? Can I say that the node number 1 and node number 2? Can I say that the node number 1 is having a frequency of 14 and this E, the character E, is having a frequency of 16, right? Node 1 is having a frequency of 14 and character E is having a frequency of 16, right? So I can make E here. I can make E towards the right. Then what I can do is, I can join these two, and I'll be making a node 3. Let's name it as N3, right? Node 3, N3. Let's name it as N3 for better clarity, right? So this is nothing but N3. N3 will be having a size of 30. Can I say this? Yes, I can. N3 is having a size of 30. Notice what I'm doing. I'll be telling you why I'm doing this, but first let's try to analyze what is happening here. Okay, so this much part is done. Now you have N3 is having a frequency of 30, right? After this, what you will do is, after this you can see, what if 2 non-leaf have the same frequency? I was stuck on this point. You will not be having any error in this. No. Even if they are having the same frequencies, they'll be having different types of ASCII different representations in coding, right? They'll be having different representations, so don't worry about that. This is node 2, this is what? 25, right? So now what are the next 2 nodes that I have in terms of frequency? Now this node with size 14 is done, and this E is also done. Now I have 2 nodes. The next 2 nodes that I can have is node 2, which is having a frequency of 25, and node 3, which is having a size frequency of 30, right? So now let me combine these two as well. And what will happen once I combine these two? So now let me combine these two. So this will become N4. Let's say this becomes N4, right? So this becomes N4, and the frequency combined will be 55, right? 30 plus 25, 55. I remove this. Now my node 4 is having a frequency of 45, right? So with this 55, can I say that I can take F? I check that my mini heap is having 2 characters. So what I can do is, I can have this F. Let me write it here. I can have F towards the left.
Okay.
How
And
they
this will have frequency 45.
say,
Now I combine these two. What is the overall frequency now? Notice that I was given 100 characters. Okay, I was given 100 characters. So that now the total frequency is coming out to be 100. And this is nothing but let's say node number 5. Node number 5. Now this is also done. This is also done. And now my mini is having only one character. Now my mini is having only one character, and that one character is nothing but node 5, and it is 100. So now since I can see that my node is not having a size of greater equal to 100, so that is why what I'll do is I'll do nothing from here. Right? I cannot do anything. I needed at least 2 nodes. So now this is nothing but this data structure. This tree is nothing but known as Huffman tree. Okay. This tree is I cannot do anything. This is nothing but node 5. Now this is also done. This is also done. And now I combine these two. Can I say that I can take f? I take that n4. Let's say this becomes n4. Right, so this becomes n4 and the frequency combined will be 55, right? 30 plus 25, 55. I remove this. Now my node 4 is having a frequency of 45, 45, right? So with this 55, can I say that I can take f? I take that my mini is having 2 characters. So what I can do is I can have this f here. Let me write it here. I can have f towards the left, okay? And this will having a frequency of 45. Now I combine these two. What is the overall frequency now? Notice that I was given 100 characters, okay? I was given 100 characters. So that now the total frequency is coming out to be 100, and this is nothing but let's say node number 5. Now this is also done. This is also done. And now my mini is having only one character. And that one character is nothing but node 5, and it is 100. So now since I can see that my node is not having a size of greater equal to 100, so that is why what I'll do is I'll do nothing from here. Right? I cannot do anything. I needed at least 2 nodes. So now this is nothing but this data structure. This tree is nothing but known as Huffman tree. Okay, this tree is known as Huffman tree. Right now, how does it help us? Right? How does it help us? First of all, what you will be doing here is that since you have this first part, so you will be assigning them values for every root, for every edge, the left edge, the edge towards its left. If there is an edge towards its left, then you will assign it 0, and if there is an edge towards the right, then you will assign it as 1. Okay, this is what you will do. Let me assign it. So for this node, for this edge, I'll assign it 0. For this edge, I'll assign it 1. For this edge, I'll assign it 0. For this edge, I'll assign 1. For this edge, I'll assign 0. For this edge, I'll assign 1. For this edge, I'll assign 0. For this edge, I'll assign 1. For this edge, I'll assign 0. For this edge, I'll assign 1. Let's say if you ask me what is the character, what is the overall what is the representation of a particular character, then I'll traverse all the edges up till that edge, and that will be my representation. So if I have to, let's say, represent A, if this is nothing but Huffman tree, right? Let me write here Huffman Huffman tree, right? This is nothing but Huffman tree. This data structure is nothing but Huffman tree. Okay. Now what further I have to see is what is the frequency of every character in this. So A is A. Let's represent A. So A, can I say that if I move first towards this side, so this is 1. Then I have to move this side down. This is 1 again. Now I have to move this side. That is 0. Now I have to move this side. That is 0. So can I say that A can be represented as 1, 1, 0, 0? Yes, 1, 1, 0, and 0. So A is represented, right? How do I represent B? So let's see how can I represent B. Let me raise the traversal for A, and let's see how we can represent B. So for B, can we say that for B, I'll first of all move down, that is 1. I move down again, that is 1. I move down, so that is 0. And I move towards the right, that is 1. Right? So B, notice that B is having a different representation compared to A, right? Now this traversal for B is also done. Let me traverse it for C and see what is the Huffman coding for C. I'm trying to put in a lot of effort. So if you are understanding this, if this was part is clear, please quickly give a +1 in the chat, because we are trying to put in a lot of effort together. Right? After this, how will I represent C? So for C is here. I first of all move towards right, then I move towards the left, and then I move towards the left. Okay, so this is 1, 0, 0. This C is 1, 0, 0, right? 1, 0, 0. So I have traversed for C as well. So for C, I'll be getting the code 1, 1, 0, right? 1, 1, 0, 0, 1, 0, 0, right? After that, how do I represent a D? So for D, I can move down. That is 1, then 0, and then 1, right? 1, 0, 1, 1, 0, 1. Now, how do I represent E? That is the situation. How do I represent E? So for E, can I say that I have to first go down right, then I go right again, So that is nothing but 1, 1, 1. For E, that is nothing but 1, 1, 1. That is nothing but 1, 1, 1. And let's see what is the representation for our last character, that is F. What is the representation for F? For F, can I say that the representation is nothing but 0? And which, can I say this? No, right. This much part must be clear to everyone, I hope. Now tell me which characters, can I say that I'm taking 4 bits to represent A, I'm taking 4 bits to represent A, 4 bits to represent B, 3 bits to represent C, and I'm taking 3 bits to represent D, I'm taking 3 bits to represent E, and can I say that I'm taking only 1 bit to represent F? Now tell me one thing, which character is having the highest frequency? Just let me know in the chat quickly. Which character is having the highest frequency? Just quickly let me know in the chat. Which character is having highest frequency? Quickly let me know. F is having 45 frequency, E was having a frequency of 16, D was having a frequency of 13, C was having a frequency of 12, A was having a frequency of 5, B was having a frequency of 9. So just quickly let me know in the chat, which is the character which is having the minimum frequency? A is having a frequency of 5, B is having a frequency of 9, C is having a frequency of 13, D is having a frequency of 1, D is having a frequency of not 1, 13, right? Now, and E is having a frequency of 16, right? E is having a frequency of 16, F is having a frequency of 45. So which is the character that is having minimum frequency? Which is the character that is having minimum maximum frequency? So the maximum frequency character is nothing but this 14, right? 45. So F is having the maximum frequency, right? Out of these, F is having the maximum frequency. Can I say that? Yes, I can say that F is having the maximum frequency. So if this is the case, then what will the size that F will be taking? Notice how many bits is F taking. For representing F, I'm taking only 1 bit. I'm taking only 1 bit to represent F, and it is having the highest frequency. So now, can I say that I have reduced the character which is having the highest frequency? I'm allocating it the minimum number of bits. I'm using the minimum number of bits to represent the character which is having the highest frequency. Right? Can I say this?
Whenever AI coding feels limited, you should break out of the box with MCPs. MCPs are...
Just quickly write a +1 in the chat if this was part is clear. The character which is having the highest frequency, that is, this is having 26, this is having 45 frequency, right? This is having a frequency of 45. So since F is having a frequency of 45, that is large. So the character with the highest frequency, I wanted to take minimum number of bits in the representation parts. If the character is having minimum number of bits in terms of representation, then what will happen? I will be taking minimum space for this character, right? So 45. This gives me 45. 3 into what? E is occurring how many number of times? E is occurring 16 number of times. So this will give me what? This will give me 48. D is occurring how many times? D is occurring 13 number of times, right? So this is nothing but 39.
How much is C occurring? So C is occurring for 12 times. So that is nothing but, can I say that this is 36? B is occurring 9 number of times. So can I say this 9 for the 36? C, A is occurring how many times? A is occurring 5 times. So can I say that this is 20? A was occurring 5 times. So 4 bits for one character, and 5, 4 into 5 gives me 20. 4 into 9 gives me a 36, and 3 into 12 gives me again 36, and then 3 into 13, that is for D. 3 into 13 gives me 39, and 3 into 16 gives me 48, and 45 bits for this. I'm giving only one bit, so that gives me this much, right? Let me add the number of bits. This is 5, 9, 14, 14, and this is 60, 16, and then 26, right? 26, 27, 28, 29, and then this will be 39. 39 plus 16 gives me what? 39 plus 16 gives me 55, and then 45 added. So I'm representing all the 100 bits here. Notice that I'm representing all the 100 bits, and let's see how much size I'm taking. For representing 100 bits, let me see that how much size I'm taking. So this combined is 56. Now this combined with this is what? 2. This is 92. This combined with this is 1, and then we have this 131. Then I have this and this. So this gives me 9. This gives me 7. 179. Let me add this and this. So how much this will be? This will be, I guess, this will be 4. Then this will be 1 caret. So this will be 240, right? 240. Can I say that I can represent this in 240 bits? Can I say this? Not 240. I think yes, right? Is this much part here, everyone? I'm representing this in a very less number of bits. 40. This added with this gives me what? This added with this. This gives me 4. Can you say that I can represent them in nothing but 224 bits? I think 224, yeah. 224 bits, right? I can represent them in 224 bits. I can represent these in 224 bits, right? If I have made some calculation mistake, then it might be wrong, but still it is lesser than, you can see that it is lesser than 300, right? This is lesser than 300 bits. Can I say that I compressed this? Yes, I compressed this. How I have compressed this? So basically what I have done is I have taken all the bits, notice that all the characters are unique. All the characters are unique in this. All the characters are unique. And what I've done is I've made a Huffman tree. I've tried to push them all the characters according to frequency in the main heap. And what I've done is I have made the nodes with the current node, and I've added that the new node in my list. And in my current main heap that I'm having main heap, why? Because I want the minimum characters at the top. Because I want to access the top 2 minimum characters with the minimum frequency, right? The top 2 characters with the minimum frequency. That is what I want to access. So what I've tried to do in this Huffman coding, the algorithm is based on the concept that if there is a character which is having the higher frequency, then you represent it using the minimum number of bits. F was having the frequency 45, so I represented it using only 1 bit. That is, I represented it like this, 0. So if I represent a character which is having higher frequency with the minimum number of bits, and if I represent the character which is having the least frequency with the higher bits, then can I say that I can reduce the size that I'm taking? Yes, I can reduce it, right? Everyone will agree to that, right? Does everyone agree to this? Please like the video if someone new is watching, right? Right? Is this much part clear to everyone? Is this much part clear to everyone? Please quickly let me know. I hope that this part was clear to everyone. Was it? Now the question comes that furthermore what we should do, right? So Huffman coding is a greedy algorithm. As I told you, Huffman encoding. This is a greedy algorithm, and in this, what we have done is you allocate or you represent character. You do what? You represent character with you represent character with highest frequency with the minimum number of bits. Okay, you represent character by minimum number of bits if it is having higher frequency, right? So if a particular character is having a higher frequency, then I'll allocate or I'll represent it using the minimum number of bits, right? And similarly, what will happen in the end? The character with lower frequency will be represented using higher bits, using more bits, right? Using more bits. But does this make my answer wrong? No. The character which is having higher frequency, I am representing it using the minimum number of bits, least number of bits. The character that are having higher frequency, characters which are having the higher frequencies, I am representing them using less bits. So that is why I am taking less size. And the characters which are, so if I allocated the lower bits, the minimum bits, if I represented them with the higher characters with higher frequency, so the characters which are little bit, which are occurring in small numbers, which are having lower frequencies, I can represent them with characters which are having with bits with more bits, right? And they will not take much space because they are lesser in number, so they will not take much size, right? So this is how we have tried to optimize this. Right, is this much part clear to everyone? I hope that this much part was clear to everyone, right? Is this much part clear to everyone? Please quickly let me know. Please quickly let me know, only then I'll be able to proceed ahead. Is this much part clear to everyone? Please let me know. So I'll sum this up. So this is nothing but Huffman coding. I'll sum this up again. Huffman encoding, you can say. What you do in this is, sorry, let me erase this part. So this is nothing but Huffman encoding. And what we do is element having higher frequency, or you can say number of occurrences, is given lesser bits. So lesser bits, so that it consumes lesser space. Okay, so that it consumes or takes lesser space, right? And element with the higher, which are given higher bits representations, or which are given higher bits for their representation, they are low in number, their frequency is very low. So that is why I will be able to optimize this space, right? So ultimately what will happen is my data compression will be happening in a very efficient manner. I'll not be taking much space. Like earlier I took 800 bits, right? I took 800 bits initially. Then I said that I can represent them using 3 bits each, right? So 3 bits each was, right, 3 bits for one character, right? 8 bits per character. 8 bits per character. So 800, 3 bits per character I represented, then it was 8 bits. 3 bits per character was 300 bits, right? But I said that I can represent them using 2 to 5. If there is a calculation mistake, so please you know that. But let's say if it was 225, that I calculated from my tree. So this will be 225 bits. So 225 divided by 100, so 2.25 bits, right? 2.25 bits per character, right? Or if there is a calculation mistake, then you can check. But I don't think there will be. So this is the representation. And you can see this was done using Huffman coding, right? I hope that this much part was clear to everyone. Now the question comes that what is the actual algorithm? What is the actual algorithm for Huffman coding, right? The question that comes in front of us is what is the algorithm for Huffman coding? How to make the tree, right? What is the algorithm for Huffman coding? What is the algorithm and how do we develop a program? We can easily drive and we can say we can do this, but how do you actually implement it in a program? And you know that this question has been asked in companies like Microsoft, Samsung, and Flipkart and Amazon, right? So this is a good question. So how do you develop an algorithm? So what you do is, first of all, you create a mini heap. First of all, you'll create a mini heap, okay? You'll create a mini heap, right? After that, what you will do is create a leaf node. Create a leaf node for each unique character, right? I'm telling you about the algorithm. I'll be explaining you further. unique character, right? Create a leaf node for each unique character and then build a mini heap of all the leaves. Okay, build a mini heap of all the leaves. So what I told you, you make a mini heap, and let's say a is equal to 5 there, b is equal to 6 or anything like that. You put all the frequencies there, right? This is what I was trying to tell you. And initially they will be behaving like a leaf node, right? They will all be behaving like a leaf node. After that, what you will do is, what you will do next? Next there will be the, let's say there is a step 3. Okay, there is a step 3. This is step 1. This is step 2. This is step 3. So in the third step, what you will do is you will create a new node, right? Create a new internal node, right? The new node was merged, so it was internal node, new internal node. And what you will do is add with frequency in this new node. What will happen? The frequency will be what? N1 was equal to, let's say what? Frequency of the minimum character plus the second minimum character in the current mini, right? Frequency of the two characters that I have taken out recently from the mini, right? So this will be the frequency, right? Frequency is equal to a plus b, let's say, or like this. I'm giving you an example. That let's say node 1, if there was node 1, then for that a plus b, right? The frequency of a plus the frequency of b will be the overall frequency, right? So that is what it will mean for a particular node. I'm taking n1. So similarly, you will do it for all the nodes. Let's say if you made the number of nodes, how many number of internal nodes you will require, right? For that. Now what you will do with this? What you will do with this? Then after that, what you will do is you will extract. You have extracted the nodes, right? So extracted node will be one node extracted node. Among the extracted node, what will happen is among the extracted nodes, one node will be made for one node for left and one for right. Right. So what do I mean by that? What do I mean by that? So I mean that let's say if the frequency of A was 5, if the frequency of A was 5, if the frequency of A was 5 and the frequency of B was let's say 9, so in that case I was putting A as the left node and B as the right node, and then there was a node N1, right? There was a node N1 with the frequency 15. So for towards the left, I was assigning for the edges, I was assigning the left edge with 0, right edge with 1, right? So for following this pattern, I need to do it like this. I need to do it like this. Okay, I need to do it like this. So what I'll be doing is for the left node, node, I'll be assigning the frequency minimum among the two, whichever is minimum. So 5 is minimum among 5 and 9, so I'll make it the left, and 9 is maximum among 5 and 9. So I'll make it the right, and then this is the internal node, new internal node that is obtained from the combination, right? And that is, you can watch the video back. I have explained how do we make a tree in this part, right? After this is done, what we will do next?
सोचो कोई ऐसा कोर्स हो जिसमें हमें ये पता लग जाए कि स्टॉक मार्केट में कौन सी स्ट्रेटेजी प्रॉफिट है.
After this is done, right? Repeat steps 3 and 4. Okay, you have to repeat steps 3 and 4. Right? Tree that I have. How do we actually make this tree? Yeah, right. So this is the code part for this problem. Okay, just give me a minute. And let me refresh this so that I can show you again. Okay, so if this much part is clear, please like the video. Okay. So right, yeah. So let me show you the code part for this problem. How you will be actually implementing this problem. So first of all, what you will be given is you will be given a string s.
स्ट्रिंग एस दे रखा है। प्रायोरिटी की फिर एक फॉर लूप चला टाइम न्यू नोड फ्रीक्वेंसी ऑफ आई, फिर इसमें पुश कर दिया सारे इसका अपने फ्रीक्वेंसी ये नोड बना के पुश कर रहे हैं उसके द्वारा। ठीक है while mh dot size not equal to 1 फिर node star left mh dot top फिर mh dot pop करेंगे फिर node star right आएगा फिर फिर node star parent भी बनाएंगे रे इक्वल टू न्यू नोड लेफ्ट का डेटा प्लस राइट का डेटा फिर पेरेंट का लेफ्ट लेफ्ट होगा पेरेंट का राइट राइट होगा फिर एमएच में पुश कर दिया अपन ने पेरेंट को ओ फिर नोड स्टार रूट एमएच डॉट डॉट एमएच डॉट डॉट आंसर फिर प्री ऑर्डर रूट ये ठीक है पहले नोड का इम्प्लीमेंटेशन भी लिखना है ये सब तो देख के लिखना पड़ेगा पे अभी तो फिलहाल डेटा स्ट्रक्ट नोड स्टार लेफ्ट नोड स्टार राइट नोड एंड वैल data, val, left, null, struct, cmp, bool, ऑपरेटर। ठीक है, ये तो अपन ये लिख रहा है, नोड स्टार एल, नोड स्टार आर, रिटर्न। फ्रीक्वेंसी जिसकी सबसे ज्यादा होगी वो टॉप पे होगी, ऐसा कहना चाह रहे हैं। है ना? फिर प्री ऑर्डर भी लिखना है, प्री ऑर्डर, एक नोड स्टार आएगा, रूट, फिर स्ट्रिंग आएगा, फिर वेक्टर ऑफ स्ट्रिंग आएगा, फिर इफ नॉट रूट, रिटर्न।
Right. The mini will consist of node and then vector of nodes, right? Because I want to make a mini.
If not root left and not root right, push back as pre-order। हम देखेंगे। 311 सब्ज हो गए भाई हमारे। L dot data was not declared, expected at 20। क्या expected था? कितने आशिक मेरी चाहतों तले तेरा हौसला जाने तेरा है वो ले आई तेरी अब तेरी सादगी. There are N houses and P water pipes in Geek Colony. Every house has at most one pipe going into it and at most one pipe going out of it. Geek needs to install pairs of tanks and taps in the colony. Every house with one outgoing pipe but no incoming pipe gets a tank on its rooftop. Okay. Every house with one incoming pipe and no outgoing pipe gets a tap. The Geek Council has proposed a network of pipes where connections are denoted by three inputs: AI, BI, DI, denoting the pipe of diameter DI from house AI to BI. Find a more efficient way for the construction. I mean, I have to find minimum the diameter of the pipe wherever possible. Hmm. मतलब क्या है ये? पर ये कनेक्शन है कनेक्टेड है वो कैसे? Which house? Connected components निकालना है. तेरा ये खूबे तेरा है. Na 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 na. एन और पी क्या है? मुझे क्या भाई, किस चीज का देखा है? सेवन स्टार्ट लेके पर अब any submission? No. Oh. No, 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 no.
Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Then we would start right away. With this. Let us see without telling only. Okay. So good to go. So we would now start with this procedure. Okay. So today we would be discussing yesterday's problem of the day. That is water connection problem. Okay. This has a success percentage of 57%. This is the medium level problem. Okay. And let's not see this tags because this gives an obvious relation. Okay. Moving forward with this. The question seems quite confusing, but if you visualize this question, then it would be damn easy. Okay. How you should visualize and all, I will show you. Okay. Let me make it a bit small. Okay. Start with today's question. Today's question would be damn easy. Don't worry. It is damn easy. So what it's trying to tell is every house in the colony has at most one pipe going into it and at most one pipe going out of it. Okay. So at most means what? What it is the maximum limit. So at most one pipe can be there or else no pipe can be there. Okay. So let's take the position. Well, we would take the max position. That suppose we have a house. Okay. It has a pipe entering into it and it has a pipe outgoing. Okay. One pipe is incoming and one pipe is outgoing. Okay. And this is a house. Okay. Just try to visualize every line and you would yourself get the answer. Okay. So moving forward, let's just move forward. Tanks and taps are to be installed in a manner such that every house with one outgoing pipe but no incoming pipe gets a tank installed on its roof. Okay. So what it's telling is suppose we have a house where we have only one outgoing pipe. Okay. So what should we install here? We should install here a tank. Okay. So I would write a tank. Okay. This is an outgoing pipe. Good to go. So next, every house with only an incoming pipe and no outgoing pipe gets a tap. Okay. So now incoming pipe would be like this, and we would install a tap here. Okay, till now this should be clear. Okay, and now if you understand this, then it is absolutely clear. Okay, I would tell you how. Given two integers n and p, denoting n would be the number of houses, so I just write n houses. Okay, this is how I do. When I don't get the problem statement. Okay, so P is the number of pipes. Okay, so P is the number of pipes, whatever be the relation. We are not interested now, but we would be interested now only. The connections of pipe among the houses contains 3 input values. Earlier we weren't interested, now we are digging deep into it. What it is telling, let us see. It is given 3 arrays. Okay, so we have AI, BI, and DI. Okay, so what it is trying to tell. Okay, let me just make it this. Okay, we are now this. Okay, so now denoting the pipe from diameter D from house AI to BI. Okay, so we have a linkage from house AI to house BI. Okay, with the diameter. Okay, this is a pipe. Okay, let me draw a pipe now. Okay, just see this thing. You have AI, you have BI here. Okay, let me draw a pipe now. Okay, okay, good to go. Okay, good to go. So this is a pipe, and the diameter of this pipe is, let me draw it with the blue. Yeah, so diameter is DI. Okay, we have a pipe from AI to BI. Okay, so it would be an outgoing pipe. Okay, from AI and incoming pipe to BI. So what would be the direction? Direction would be like this. Okay, just this, just understand this. Okay, the output will contain the number of pairs, and I will tell you that is not a problem. Okay, so now am I clear with the problem statement explanation or not? I tried to explain everything visually. Okay, so that you have a better understanding of the problem statement. So let me recapitulate what I told. Okay, what I told is at max house, till then just give me a +1. Okay, okay, so at max a house can have 2 pipes. Okay, one incoming and one outgoing. This is what I told here. And then if a house has only one outgoing pipe, then it would install a tank in it. Okay, and if the house has only one incoming pipe, then it would install a tap in it. Okay, now talking about this, what is n? N is the number of houses. Okay, and then P is the pipe, and in every P, what is there? It is given as AI, BI, and DI. Okay, each element correspondingly. Okay, what does AI, BI means? AI, BI means that we have a pipe from AI to BI, outgoing from AI to BI, and the diameter is DI with the moving from this. Okay, how to fix direction, sir? It is absolutely given here. That is why I try to visualize this. See this thing. Okay, denoting the house. Okay, from what does from means? वहाँ से, मेरे तरफ से. Okay, okay, take knowledge from me, मेरे से. Okay, so from house AI to house BI. Okay, to house BI मतलब A से BI तक. Okay, just see this thing. और यहीं पे how to fix direction हो जाएगा from house AI to BI. Okay, it should be clear. Okay, moving forward, I should be clear with this. Many people did not reply. May I move to the explanation now? Okay, so to solve this problem, let us first understand the problem statement. Okay, so what we need to do is we need to find the efficient way for the construction of network of pipes. Okay, so whatever is there, and we don't know what is the efficient way and all, we don't know anything. Okay, we don't know anything. We are just told the output would contain the pairs of tanks and taps installed in the first line, and T installed in 3 houses and the house number of the trap and the minimum diameter of the pipe between them. We are not interested in that. Okay, so just now we don't know what is the efficient way. We don't know now, but you would yourself tell me that you are understood the efficient way. How? I would tell you. Okay, so let's make this also a little bit smaller. Okay, so what we were told, we have a relation from AI to BI with the diameter as DI. Okay, so if we have a relation, okay, if we have a relation from this to this, and we have a diameter also, then this is clearly a graph problem. Okay, you can solve this, you can visualize this problem in terms of graph. That is what it tells. Okay, now next thing is that it is only one way. Okay, so it is a it is a directed graph. Okay, what I told, I just messed up. Okay, it is a directed graph. Okay, it is a directed graph. I told correct, but just, actually class में पता रहता है भी confuse हो जाते हैं. Okay, good to go. So we have a relation from 7 to 4. Okay, so we would just write 7 and then write 4. And what would be the weight of it? The weight would be 98. Now in graphs we talk about weight, so diameter would be taken as 8. Okay, so now it is complete. So I would just remove this. Okay, this is complete. Then we have 5 to 9 with the weight as 72. So 5 to 9 with the weight as 72. Good to go. So next what we would do is 4 to 6 with the weight as 10. So 4 is here.
SP Jain was the perfect choice for me. AI is changing everything from what we shop to what we eat to what we do. So a degree with AI plus business sense just made
4 to 6 with the weight as 10. Okay, moving forward, this is also done. Okay, then 2 to 8 with the weight 22. 2 to 8, just write 2 to 8 somewhere. 2 to 8 with the weight as 22. Just remove this, remove this, remove this. Then we have 9 to 7 with the weight as 17. So 9 to 7 with the weight as 17. Okay, so just remove this. Okay, and the next thing is that 3 to 1 with the weight as 66. 3 to 1, there is no 3 to 1 anywhere. 3 to 1, no. 3 to 1 with the weight as 66. Okay, this is also clear. Okay, let me just check it. I think I made a mistake somewhere. 7 to 4, yeah, 98. 5 to 9, 72. 5 to 9, 72, yeah. 4 to 6, then 10. 4 to 6, 10, yeah, good to go. 2 to 8, 22. 2 to 8, 22. Yeah, 2 to 8, 22. Then 9 to 7, 17. 9 to 7, 17. 3 to 1, 66. Okay, anywhere I missed something, seems like. Can you spot the error? I'm not able to spot it actually. Okay, so connect 9 with 7. Okay. Thanks a lot. Okay. 5 to 9 with the weight as 72. Sorry. Yeah, छोटे मोटे mistakes होते रहते हैं. I can't help it. Okay, so okay, thanks a lot. Who told me? Srijan Prakash, thanks a lot. It's out of finding all the disconnected graphs in the directed graph. Disconnected graphs or components. Okay, so 597. Yeah, thanks a lot. Graph coding also thanks a lot. Okay, moving forward, just see this. Okay, so we need to find an efficient way. So we can see that this would install. Okay, suppose 3. Let's take with a smaller example. So 3 has an outgoing pipe. 3 has an outgoing pipe. So 3 would install what? 3 would install a tank. 1 has an incoming pipe. So 1 would install. Okay, 1 would install a tap. Okay, so how can I relate tap and tank? Writing tap and tank is a little different. Okay, just that. Okay, one is tank. Okay, let's take a better one. Okay, so let's take that cross is a tank. Okay, and then box is a tap. So this would have a tank. So we would mark here like this. This would have a tap. So we would just mark here like this. So this would be 2 to 8. Yeah, it should be 2 to 8. Yeah, 2 to 8. Okay, good to go. So 2 to 8. So this would have a tank. This would have a tap. Okay, so this would again have a tank. This would have a tap as well as
टैंक टैप का तो कोई टेंशन ही नहीं है, पैर ही बताना है.
as well as both. Okay, tap and tank. Okay, so next thing is that this is also there, and this would have a tap. Okay. Now the thing is that it is a common procedure that suppose we have a pipe. Okay, we have a pipe of 10 centimeter. Okay, suppose this is 10 centimeter pipe, and we have a smaller pipe. See this thing. This is a smaller pipe. Or suppose this is a smaller pipe. This is a bigger pipe with a greater diameter. This is a smaller pipe with less diameter. This is not a pipe, but visualize this as a pipe. So see this thing. So if you pass water with this pipe by joining it, then this diameter would be considered. Why? Because how much water would come, this would pass within this only. Okay, so you need to take the minimum diameter. Okay, so suppose ये minimum diameter वाला concept नहीं आता. Suppose भैया I thought the minimum diameter, how would I get the diameter and all. So, okay, so it is told that minimum diameter of pipe between them. Okay, so this is it. So now we need to tell the minimum diameter of pipe, first thing, and next thing is that house number of tank. Okay, house number of tank was this, house number of tap was this, with the minimum diameter of pipe. Okay, so let's do this. House number of tank. What is house number of tank? This one. This is having a tank, so answer would be 5. Okay, house number of tap. Okay, 5, and tap is here. And the minimum diameter, what is the minimum diameter? 72, 17, yeah, 5 to 6, the minimum diameter is 10 itself. Okay, good to go. Moving forward, 2 to 8, tank and tap. Okay, so 2, 8 and 22, 3, 1 and 66. Okay, is this clear or not? So what is the thing? I would just explain you the further, but let me know if this is clear or not. We just visualized, we just drew this test case in a pen and paper, and we are getting the answer. So we can get from the answer that, what we can conclude from the answer. Suppose we have some elements like this, and like this, and like this. Okay, so we can see that the first element would contain tank, and the last element would contain tap. Okay, and in between elements would contain both or nothing. We are not interested about that. So whenever we have a connected component, the first component would connect, the first component would have tank, and the last component of that graph would have the tap. Okay, I should be clear with this. Okay, now moving forward, now suppose there is one more other component there. Okay, and this is having a tank, and this is having a tap. Okay, so we can see that this answer and this answer can be solved individually, like they are different components of the graph. Okay, so what is the first thing that we need to do here? Okay, so suppose there are, so whenever we talk about finding connected components, okay, okay, so what are the two major ones? BFS and DFS. So if you ever just remember this, okay, this can be taught, but it is just for the fact that whenever you come across problem of finding components and all, DFS is the most optimal one in most of the cases, not all the cases. In most of the cases, in the components period, DFS would be the one that would help you. How? I would tell you. Okay, suppose we have a graph like this. Okay, suppose we have a graph like this, and we have a different graph like this. This is how we would have the graph. Okay, moving forward, what is DFS? DFS tells us that we would visit a node. Okay, we would visit a node, then visit its neighbor. Okay, this is DFS. This is DFS. Sorry, this is DFS. I'm extremely sorry. Okay, this is DFS. What is DFS? We just visit a node, then we visit its neighbor. We again recursively visit the neighbors of that next node, and we would do it. So let's start with the first node. We are visiting it, and we would visit the neighbors of this. So again, we would visit this. We would again visit the neighbors of this, and when we have visited all the neighbors and all, then we would simply return. Okay, this is how we would report the first component, and we would completely traverse it. Okay, next thing is that we would again visit this, again visit this. So this is how DFS helps us in finding anchor components. Okay, good to go. Now the next thing is that we had 1, 2, 3. Then suppose it is 4. Okay, so we need to report this element first. Okay, this element is tank. Okay, this element is tap, as I told. Okay, then the next thing is that we need to report the first the tank, see house number of the tank, then the house number of tap, and then the minimum diameter. Okay, so we can see that minimum diameter can be calculated by taking the minimum while traversing from the first node to the last node. Okay, so we can tell what is the minimum diameter. That is absolutely simple. Okay, एक आगे में traverse करना है, उसका जो भी minimum होगा उसको report कर देना. That is simple. Okay, that is not the problem. But reporting the first node as the tank and reporting the last node as the tap is a difficult part. Okay, so this is not a difficult part to be honest. But if you just know this trick, okay, I found out this trick by myself. Okay, I never wrote this trick. Okay, the thing is that how would you be given the relation of just this graph? You would be given like this. We won't be writing the diameter and all because that is a different thing. We are not interested about the diameter. The diameter part is over. So how we would have this? We would have this like this: 1 to 2, then 2 to 3, then 3 to 4, and this is how the graph is built here. This is how the graph is built now. Let's start building. Okay, so we can see that the tank one. Okay, we can see tank does not. In tank there is no incoming relation. Okay, what I want to tell is the house which is having a tank does not have an incoming pipe to it. Okay, to be more clear and precise, it will never have like this. It would never have like this. Okay, so the node which is having no incoming is kind of tank for now. Let's see. Yeah, this is having incoming. This is having incoming. This is having incoming. So we can conclude that the node which is not having any incoming pipe to it, that is the tank. Okay, so we can just conclude that tank is equals to no incoming pipe. Okay, and what is tank? Tank is the start of the traversal. And now talking about the tap. Okay, tap would be just the reverse of this. Okay, what would be the tap? Okay, in tap there would be no outgoing pipe. We can see that this tap has no outgoing pipe to it. Okay, and see this has an outgoing pipe, this has an outgoing pipe, this has an outgoing pipe, and this has an outgoing pipe. Okay, so we can conclude that no outgoing. Okay. No outgoing, and this would be the end. Am I clear till this point or not? Is this observation very clear or not? Okay, in graph problems you should always try to build the graph from the example, then you would understand that. Okay, this is a what you can say advice from my side, which is completely on my personal basis. Okay, moving forward with this, we know that the tank, okay, and the node which is not having an incoming, that would be the tank. So what we can write is let's make an array of incoming as well as outgoing. So I would be writing in, okay, and I would be writing out, okay, and this is incoming, this is outgoing. Okay, so let's draw the array of both. Okay, array of both, and that would make the more clear to it. Yeah. Okay. 1, 2, 3, 4. Good to go. And what are the elements at this point? We have 1. Okay, I'm extremely sorry. We have 1, we have 2, we have 3, we have 4. This is how we would just build the array of the size of the nodes, of the size of the houses. Okay, moving forward. See, we know that we can get a relation from 1 to 2. So if there is a relation from 1 to 2, okay, what I can say that if 1 to 2, okay, from AI to BI, it is given that we have a relation from AI to BI. Okay, so if there is given a relation, then we can tell that BI has an incoming and AI has an outgoing. Is this clear or not? Okay, so if there is given that 1 to 2, then 2 has an incoming. Okay, so let's mark 2 as incoming. Okay, let's mark 2 as incoming and 1 as outgoing. So let's mark 1 as outgoing. Good to go. Then 3 has an incoming because 2 to 3. So 3 also has an incoming and 2 has an outgoing. Okay, so 2 is already marked. We won't do anything because we already know that 2 has an outgoing. Okay, sorry, not 2. 2 has an outgoing here because from AI to BI. Okay, so now we can see 3 to 4. If 3 has a relation from pipe 3 to 4, then 3 has an outgoing. Okay, so 3 is having an outgoing and 4 is having an incoming. Okay, is this quite clear or not? Okay, and the solution becomes absolutely clear at this point of time that see, I told the tank does not have any incoming, so tank is not having any incoming. Tap does not having outgoing, so tap is not having an outgoing. Okay, so now we would simply traverse from 1 to n, and we would check if a node, if it has no incoming but has an outgoing, then we would start from that point of time and we would move forward. Okay, this is what we would do, and we would get the result. Okay, and the next thing is that we would just traverse from 1 to n. Okay, and we would check which number is not visited and it is having an outgoing but no incoming. Okay, so we would start traversing from that point, and the node which we visited the last, that would be the outgoing. So that would be the incoming, that would be the outgoing. Good to go. Next thing is that while we traverse, we would keep the minimum value. Okay, is it like doubly linked list? Yeah, you can tell it, but as it was given the tag as graph and DFS, and understanding this in terms of graph and all, it becomes quite clear. Okay, what I thought and what I assumed. That's why I didn't went on the doubly linked list side. Yeah, it can be treated as a doubly linked list and can be solved too. I checked in the comments, and when people solved it using doubly linked list, but the graph was more intuitive, more understandable, and that is what the solution is given. Now I most of the time go with the solution that is given in text format. Why? Because suppose you didn't understand this question question, you're not able to solve this question. What is the first thing that you should do? First thing that you should do is you should try it from your side, and then you should look at the video tutorial. After looking at the video tutorial, you should consider reading the article or the solution to it. Why? Because after reading the theory and after watching the video tutorial, it would be retained in your mind for a longer period of time, and you would get the idea much better. That is what it should. That should be the procedure which I followed, and that is the general procedure which I think most of the people tells us to follow. And to be honest, my father and mother only told that भाई बेटा वीडियो भी देखो तो साथ में बुक पढ़ाई भी करो, because बुक पढ़ना भी important है. In the same way, आजकल तो बुक होते नहीं है, so you should read the article. Okay, good to go. Moving forward with this. So how can we do this? We would simply start a DFS from the node which is not visited, and we would simply visit it. Okay, so may I move to the implementation now? After Ahmed start replying, and I would move to the implementation. If at any point of time you didn't get what I told, then just let me know. I would explain you the whole process. Not the whole process, the part where you didn't understand. Okay, can I have a quick +1 in the chat? I would be waiting for just 1 minute for doubts, and let me know if there are any doubts or not, then we would just move forward with this. Okay, having explained it for 53 minutes. Okay, so good to go. I didn't tell that it is explained bad, he explained much better, but the time he took was a very long time. Okay, moving forward with this. So let's start with the implementation now. So as we do DFS and all, we would start with the visited array, okay, and then we need to report vector of int, vector of int. So we would just initialize answer, and this memset is used to make every value as 0, that is false, okay. So we would start with n+1 size and every value as 0, out as n+1 size with every value as 0. So we would mark everything false at present, okay. So then what we would do is we would start building the graph itself. How we would do? Okay, suppose we have from AI to BI, okay. So we know that B has an incoming and A has an outgoing. So B has an incoming and A has an outgoing. We are just marking both this true, and then we are pushing from AI dot push back B with the pairs. This would be the weight, okay. And then what we would do is we would start from 1 to n, okay. And if this in, that is there is no incoming and outgoing is present and it is not visited, then we would start. That is, this S would be the first one, this E end would be told by the DFS only that what is the last DFS tell me what is the last node you visited. That is the and minimum weight is I have initialized to into max because I need to tell the minimum. So to take out the minimum, we need to take out the maximum so that we catch even the lowest minimum. Okay, largest minimum. Okay, that is what the thing. Okay, so what we would do is we would simply pass this at the end. We would just insert this in the answer. Minimum weight is I have initialized to into max because I need to tell the minimum. So to take out the minimum, we need to take out the maximum so that we catch even the lowest minimum. Okay, largest minimum. Okay, that is what the thing. Okay, so what we would do is we would simply pass this at the end. We would just insert this in the answer. So let's look to the DFS one. Okay, so we would mark the first thing visited because अगर हमें दिया गया है हम पहले तो लिख देंगे टाइम में या हमने visit कर लिया. That is what. Then we would visit the neighbors of it. It is absolutely simple. And if the neighbor is unvisited, what we would do is we would simply see what is the minimum, and if it is the minimum, we would make it the minimum. And suppose हमारे पास 1 to 2 to 3. Okay, suppose we are on the DFS of 1. So we can
ई मेरा 0 पे 1 पे ये लगेगा. एंड तक चलेगा। पी तक पी क्या दिया है?
Okay, suppose we have from AI to BI. Okay, so we know that B has an incoming and A has an outgoing. So B has an incoming and A has an outgoing. We are just marking both this true, and then we are pushing from AI dot push back B with the pairs. This would be the weight. Okay, and then what we would do is we would start from 1 to n. Okay, and if this in, that is there is no incoming and outgoing is present and it is not visited, then we would start. That is, this S would be the first one. This E end would be told by the DFS only that what is the last. DFS tell me what is the last node you visited. That is the and minimum weight is I have initialized to into max because I need to tell the minimum. So to take out the minimum, we need to take out the maximum so that we catch even the lowest minimum with time. Okay, moving forward with this. So let's start with the implementation now. So as we do DFS and all, we would start with the visited array, okay, and then we need to report vector of int, vector of int. So we would just put an answer, and this mem set is used to make every value as 0, that is false, okay. So we would start with n plus 1 size and every value as 0, out as n plus 1 size with every value as 0. So we would mark everything false at present, okay. So then what we would do is we would start building the graph itself. How we would do? Okay, suppose we have from AI to BI, okay. So we know that B has an incoming and A has an outgoing. So B has an incoming and A has an outgoing. We are just marking both this true, and then we are pushing from AI dot push back B with the pairs. This would be the weight, okay. And then what we would do is we would start from 1.
सतर को छोड़ के खून चूस ले तू मेरा खून चूस ले मेरे होने मन में तो है खून चूस ले। विजिटेड भी 0 हो। ठीक है, समझ गया। अब आगे जाते हैं। डॉट फर्स्ट है बी, अगर बी ऑलरेडी विजिटेड है, बी विजिटेड नहीं है, तब वो जाएगा आगे बी लेके। लेकिन अगर बी विजिटेड है ऑलरेडी,
simply pass this at the end. We would just insert this in the answer. So let's look to the DFS one. Okay, so we would mark the first thing visited because अगर हमें दिया गया ना तो हम पहले तो लिख देंगे ना डायरी में या हमने विजिट कर लिया. That is what. Then we would visit the neighbors of it. It is absolutely simple. And if the neighbor is unvisited, what we would do is we would simply see
आंसर लिखा मैनसेट विथ 0, ये तो अपन ने बस 0 इनिशियलाइज किया है, बराबर एक इन बनाया, ठीक है, एक आउट बनाया, ठीक है, n+1 से बराबर, और